I think, but just too much for my object-oriented brain. So next up, all the way from Zurich, we have...
No worries, no worries. Everything.
I'm really good. How are you doing?
Hi, I'm really fine. It's a bit strange doing that from home, but all good.
It's all good. You're going to do great. And now you're going to talk to us. Oh, you're in with the cool kids as well, aren't you? You're talking about building real-time applications with Blazor and GraphQL. Is that right?
Exactly. We are taking Blazor to the next level today.
Oh my goodness. Okay, well, I'm going to share your screen now, Michael, and let's see how we can do this. So over to you.
Thank you. Hi, everyone. Today we are talking about Blazor and GraphQL, and we are going to take Blazor to the next level by using GraphQL and introducing real-time data fetching capabilities to it. So why real-time data fetching capabilities? Because they make your applications really engaging with the user. You don't have to constantly refresh for new bits. You just get them as they come in. A good example for a real-time application is actually Slack. And Slack, on top of that, is really built on GraphQL. So it's a very good example here. In Slack, I can interact with people, I can write messages, and as they respond, I get the messages back. And I thought that's a good application that we could build in such a session. So we are taking, not fully featured, but some kind of a Slack clone with Blazor to show that off. Okay, so what we are going to build is basically the simple layout that we see here with the left people sidebar where we have all the users I can interact with, and then a content area where I can then chat with one of the people. And at the end, you can help me to debug that by sending me messages right into my debug session. So let's get started. So first, let me pull up my Blazor application. At the moment, this Blazor application really is just an empty shell. Just let me show you that. So we are just compiling it and running it, and then localhost 5000. It's nothing else than a background color at the moment. But we are going to change that. So the first thing that we want to build here is the left-hand sidebar where we have all the users. In order to do that, we need to fetch some data with GraphQL. In GraphQL, the responsibility between fetching data and between the front-end developer and the back-end developer are reversed. So essentially, the front-end developer defines the interface between the server and the front-end by himself, or by him or herself. Okay, for that, I switched over to Banana Cake Pop. It's also built by our open source project. It's a GraphQL IDE based on Monaco. And we are going to define our first GraphQL call. So in GraphQL, queries start with a little keyword. In this instance, we are using query because we want to fetch data. And then we want to fetch the people that I can interact with. So I'm naming this operation here, get people. And essentially, this is my GraphQL operation. And here I can define what data I want from my API. So I'm going to say I need the people field. And from that, I want the nodes. And this is a paging API. So this is the nodes of my current page. We will not bother with paging today, so just bear with me. So the next thing is I'm picking all the data that I need from a person. So for my little sidebar, I need a name, an email, the is online status. So if the user is online or not. I want an image UI, maybe a picture of that user, and last, maybe a timestamp when this user was last online. With that, I actually have everything, but this particular API also lets me sort the set of data, my list here. So I'm sorting that by name, ascending order, and then let me fire that up. By the way, sorting is not built into GraphQL. It depends on your API. So don't compare it to OData or things like that. OK, let me grab this query, because that's exactly what we need. We defined what data we need. We tried it out. We got a very closely aligned result. So let's take that to our Blazor application. So how do I do GraphQL with Blazor? First, we created a GraphQL client that is called Strawberry Shake. And this complements our GraphQL server, which is called Hot Chocolate. So cold drinks for the front end, hot drinks for the back end. Okay, in order to get this all initialized, we need to use a global tool, which is called dotnet GraphQL init, to just initialize our initial GraphQL client. So we're grabbing the URI here from my GraphQL IDE, and then saying GraphQL init, and we also give it a name. We call it chat. It's our chat client. We start generating it, and what we can see is that something was dragged down from the server. In this instance, we can see there's a chat GraphQL, and it's basically the schema, the representation of all the types that we have in the backend. And we need that to compile our queries against that and generate from that C#. So the next thing is we need a place to put our GraphQL queries. So we create a new file, queries.graphql. You, by the way, can name it anything. Foo, ba. It just has to end with GraphQL. And then we grab our query. Let me just put that aside here so we can easier get to the IDE. Okay, and then we just paste it in and compile our GraphQL, our Blazor application. Okay, and what we can see here is that now we have generated a lot of types. And if I, for instance, look at the iPerson CS, I can see that I generated a person that has exactly the fields I defined in my query. So the front-end developer essentially defines the interface between front-end and back-end. And also, if I look at the chat client, I can see that the operation get people translated into a method on my client, get people async. Okay, so let's head into the components and use that client to build out our left-hand people list. Okay, so in the components, I have the main Razor component. In SPA application, we have the concept of smart and dumb components, or stateful and stateless components. Main will be our smart component or stateful component that does all the interaction with the backend, holds all the state. And then we have like our stateless components, which are much more reusable, that represent the list. And how that works is that in Blazor, or in SPA application in general, the smart components will push data down its component trees to the stateless components, and the stateless components can then interact through events with the smart component. Okay, so what we have here is the people list that represents really the list of users that we can interact with, and we essentially get some data in here, like an is loading indicator, and also a connection, which is our paging type for the people. So essentially a list of people. And then we have this person item, and you can see the person item gets a user in here, and it's from the type iPerson. And we are essentially binding all our components to parts of our data structure that we generated from the client. So let's put that together. Let's go in our main Razor and add the people list first. Let me just import the namespace here so that everything works. And then I can see the parameters that I used here basically translate to attributes on my Blazor tag component tag here. And I need to add here some fields so I can bind these data to some fields in my code. So let's do that. So I'm adding here my general initialize function where I will fetch the data for this component, and I'm adding some fields here where I bind the data to. Next, we have still there an event. If I click on a person, I want to load the messages. So let's put just the empty event methods in here that we will use later. Okay, with this, everything would compile. Now let's fetch some data with our client. in order to use our client, let's inject this with our dependency injection support in Blazor and say we need a chat client here, which we call chat client. Okay, and then let's fetch the data. So we are using now the getPeople method on our chat client to fetch some data, ensure that this data has no errors, and then we are just grabbing the people list from that and assigning it here to our field. Last but not least, we are setting our loading indicator to false and signaling that the state has changed and the components are being updated. This should already run, but we still need to put in some dependency injection logic so that our client is injected well. So we're going back to our builder here in Blazor and saying builder.services add chat client. And then essentially everything is set up. All the dependency injection code is actually generated. But we need to something to communicate with the backend. So we need a way to interact with our server. So we are adding the HTTP client factory here and configuring a client that basically has all the details how to communicate with our GraphQL backend. Last but not least, let me put in a token here, and we are ready to go. Let's debug our client so far. .NET run. And that should come up momentarily. Okay, let's refresh that. Awesome. We have our left-hand side bar. We have all the people that we have. Was not so difficult. So let's move on to the next thing. The next thing is when I click on somebody here, I want to have some message bubbles here, be able to write messages to that person and interact with the person. So for that, we essentially go back to our GraphQL IDE because we need to add more to our interface, to our server interface. So we need a method. We need an operation to fetch all the messages. So let's write that. Query get messages. But before we write that, actually, let me introduce one more concept of GraphQL to you. In GraphQL, we have something called a fragment. And a fragment is our primitive of composition in GraphQL. It lets us create fragment hierarchies as we create component hierarchies in our UI, in our Blazor component. So this closely aligns. And in order to shape our client, really, we are now using fragments. And you will see the benefit of that in a couple of seconds. So we are creating a fragment called person, which actually applies to a person. And then we are just grabbing the fields here, putting them in here, and refer from this query to the person. Let me reformat that. Let's do that in a minute. Okay, the next thing is we want to fetch the messages. And for the message, we actually want to fetch the messages that I have with a specific person. So let's put in an argument here, which is actually called a variable in GraphQL. And then we can pick from our queries. For instance, in this instance, we are getting the person that I want to talk to. So we are loading the person by email. And then we are grabbing from that person the messages that I have with this person. And then again, we are not putting the fields in here. We are creating a new fragment, which we call message. And then we are filling in the fields that we need. We need the ID, we need the sender. We leave that out for a second. We need the recipient. And then we want the direction of the message, so we know where to put the message bubble, the text that the user is sending us, and the date when this user sent us this message. Okay, so here we actually need something from person, but we actually just need the top 3 fields from person. So what we can do here is essentially creating another fragment on person. And in this instance, we are calling it participant. Participant. And then we are getting rid of these guys. And okay, there's no need to keep that around because we just can refer to the participant fragment here. And then down here, we can also reuse the participant fragment. Okay, with this, we finally can put in here our message fragment. and are almost done with our get messages operation. So we just again put some order in here. So our messages are ordered by the send date, and we're done. The second part we need is a way to send in new messages. And changing the server state in GraphQL is called mutation. So I'm starting here with mutation, and I'm calling my operation send message. And again, we need some arguments to pass in, the email to which I want to send a message, and also the text that I want to send. It's again a string that is not nullable. Let me pass that in, and then I can pick from my mutations on the backend. In this case, send message mutation. And just let me wire that up here, putting the email into the recipient email and the text into the text. Okay. So in GraphQL, only the top field actually is the mutation. There's nothing like a nested mutation. And everything that is down here is actually querying the changed state of the server. So what we can do here is then query for the message that we just produced and reselecting that so that we get the message with the correct timestamp and all. Okay, with this, we are kind of ready. We can just copy and paste that over to our Blazor application, just put it in here. Let's recompile that. And while that takes, oh, there's a bug. Let's see. Oh no, everything's all right. So what we can see here now, with all the fragments that I introduced, is that I have a person. And this person now has only two properties and implements actually iParticipant. So I can shape with fragments how my data is structured and how it is reusable in my client components. And also I have a message, and the message now exposes a sender, which is a participant. And again, my chat client just has some more methods here to get the messages, send the messages. So it's very easy to use. Okay, so let's get back into our components. The first thing we need to do is uncomment these components that are already prepared here for the message bubble that essentially binds now to our message object here, and also use the participant sender of the message. And then I'll also get these other components in the footer, the header, just to make it nice, and an info box for some messages. And last but not least, our message list component that we will put in our main component. Okay, with that, let's put that in, the message list into this. And again, put the using in, so not to forget it. And we can see that this component actually needs more data. It needs a recipient and it needs a list of messages. So we are adding a new field here, recipient, and we are also adding a new field messages here, which is in the beginning empty, and then we need to fill that up. We already have the event methods here on click and on click send. So on click, we want to actually fetch the messages from the person we clicked on. So let's do that. My snippet didn't work. Okay, so what we are doing here is using the chat client to get the messages and then ensure, again, there are no errors, assigning the recipient to our, the person to our recipient field in the top, and also extracting the messages from the GraphQL response and triggering state has changed. So last but not least, we need to have this method where we can send messages in. So we have another interaction with our GraphQL client to send in messages. Essentially, it's the same thing. We take the chat client, send a message in, use the recipient that we already stored up there, and passing on the message that we have here. The interesting bit is then we get this message. We are querying for the changed message of this of the send message method, and are just adding it to our message list. So with this, we can just dotnet run that, and then Let's debug it. Okay, it's coming up. Now we should have, we have our message area now here. I can click, for instance, on Babats, who has two messages, hello and hello foo. There are other things like, here's Jose, I have some messages with him, so I can see, I can write messages here. So hello, Jose, let's send that. And I can see here's my message with Jose. But this is not real time. We need actually to do a little bit more to get real-time data in here. So in order to get real-time data in here, let's get back to our GraphQL ID banana cake pop and put in a real-time event. So how does it work with GraphQL? Actually, it works the same like a mutation or a query. From a user perspective, real-time data fetching is not difficult. It's quite easy. I can just write a query that says it's a subscription and signals that it's real-time, and then the server will provide this data. There's still lots to do to scale out your servers and to make sure your connections are stable and stuff. It's stateful. So there are things to do. But from a consumer perspective, it's simple. So we are saying subscription, on receive messages, and then we can just pick from our events. In this instance, I'm picking from on message received. That is my event on the server. And I can see here that this actually is a message. So again, I can use my message fragment here, and I'm essentially done. Just to make it more nice in my API, I wanted to rename this field to message so that in my client API, this field is called message. And with that, we are done here. We can bring that back into our client, into our Blazor application, recompile that all. Wait for it. Something didn't refresh correctly. Let's recompile it again. And then we basically build in the real-time event. So a real-time event or a subscription basically translates to an async enumerable in C#. So let me put that in here. And we actually called it on receive messages. And what I get back here from my client, if I call on receive messages, is essentially a iResponse stream. And the response stream is nothing else than an async enumerable of message. And what I essentially do here is just for eaching over the message stream and then updating my message list and signaling that there are new messages. So we now just need to run this event, because what it actually does is we are spawning off a task that is running while we are receiving messages and then writing these messages to our list. That's all. But we need to set up some logic to actually fetch the messages. So what we are going to do here is adding something called the WebSocket client. And this API is done by us. It closely resembles the HTTP client factory and takes away the complexity of setting up socket connections. Real-time events in GraphQL can be done with WebSockets. That's what we are using here. You could also use gRPC, or you could also use SignalR. Okay, so we almost are done. Let's get that started. dotnet run, and hope it works. And then you can help me debug that application. Just give me a second. We are lowering that down. Here's the URL that you can call to send in messages. It's also a Blazor application that just lets you send in messages. And I'm going to use also this little Blazor application to send in messages. And I know there is a 2-minute delay in this. So I will be the first. And I hope there are others who will follow. And you can see the messages are coming in. And okay, awesome. You can see the audio. There are other people now chiming in to send in data. So where can you get started with Hot Chocolate or Hot Chocolate GraphQL server? It's just go to chillicream.com. We are on GitHub. Everything is open source. And we have a great community that congregates on Slack. So be sure to click on the join Slack link on our GitHub repository once you reach that, and then have some fun with us. With that, Layla, I am done and ready for questions.
I was muted, ready for questions. Awesome. Thank you. That was great. So let's have a quick look in questions. I'm going to share my screen. Michael's just flipping over there. So the one we had here was good content. It was great. Can we use Firebase real-time databases with Blazor?
I don't know Firebase real-time database. Depends on how it works. If it has a Signal client or has a GraphQL client, sure, why not?
Super, thank you. I actually have a question as well, and mine was based on how you manage those fragments, because what I saw is you keep nesting that participant inside person.
Yeah.
Does that seems like lots of dependencies, or is that not a problem?
It is actually not a problem. You should build out your fragment nesting in order to align with your components. In the GraphQL, in the Blazor application, actually, we are now able to pass in the person to components that actually just want a participant. And in this instance, I want to nest. But there are instances where you don't want to nest. So it's up to your component design. And that's actually where GraphQL has its strengths. So it aligns with your design on the client.
Okay, that makes sense. Great. Thank you so much. And if you have any questions for Michael, make sure you tag him on Twitter. Michael, can we get the source code for what you did? Do you have a GitHub link that you can share?
Yes, I can. I will share it on Twitter. It's I have a repo with all my public speaking content.
That would be great. So we can have a look at what else you have done as well. So thank you so much for joining us all the way from Zurich. And thank you for participating in .NET Conf. It's been a pleasure to have you, and enjoy the rest of your day, and take care.
Thanks.
Bye. That was really interesting. I'm loving seeing all these different uses with Blazor. Obviously, Blazor is so exciting right now, and everything that you can do, from the different aspects of it to the GraphQL and how to connect it and run it here and there and everywhere. It's really exciting. So our next session is going to talk a little bit more about automation. Oh, I can't say it. Automation. There we go. I got it out. So I'm going to bring in Gary Ewan Park to our next speaker. Hi, Gary. How are you?
I'm good, thanks. Thank you.
Yeah. So you're joining us from a little bit further north of me, aren't you? You're in Scotland, just north of Aberdeen, I believe.
That's right. Yeah. So up in Aberdeen, just outside Aberdeen, but yeah, up in Scotland. Yeah.
Perfect. Scotland's one of my favourite places. I was there 2 weeks ago, but that's by the by. You are doing another favourite thing. Your talk title is called A Piece of Cake. Now, I'm very much into cake. I love cake, like the edible kind. I'm saying here.
Unfortunately, there's no edible cake in this talk, unfortunately. So,
what? Oh my goodness, the cake is a lie.
The cake is indeed a lie today, yes.
So you are talking about C# powered cross-platform build automation. Oh, I can't say it. Automation. I want to say automation. So without further ado, I'm going to hand it over to you. Let me bring in your screen and hand over to you, Gary. And remember, if you have questions for Gary, make sure you tag it with the hashtag .NETConf and Gary's Twitter handle, which is there underneath Gary's picture. And with that, over to you.
Thank you very much. So yes, as Layla mentioned, we're here to talk about the C# powered cross-platform build automation tool that is known as Cake. Now, before we get into exactly what Cake is, I want to make sure that we all are on the same page with regard to what a build is, because unfortunately the term build is a little bit of a overloaded term. So I just want to draw a line in the sand and make sure that we're all talking about the same thing. So what I'm referring to when I'm talking about a build is really one of the core components of that is the compilation step. So that's where you are taking your source codes, whether it's C#, whether it's TypeScript, whatever language it is, then inherently you have a compile step. That's sometimes known as the build. But in this context, what I'm referring to is the larger portion of that, which is the build workflow that we're attempting to achieve. So in terms of .NET ecosystem, in order to do a compilation, you also need to typically do a package restore. So you'd be using NuGet restore or .NET restore to bring in those external dependencies that you need in order for your compilation to succeed. Related to that, tangentially, there is typically a clean step within a build process. So that's where you are cleaning up the artifacts of your build so that you can ensure that every time you run the build, you've got something that's repeatable, that is reliable, and is maintainable. So you need to clean up the artifacts as part of that build so that the next time you run the build, essentially the exact same thing happens again. So once we've got all of these things in place, typically you would be doing some unit testing. So you want to make sure that the code that you are writing is actually doing what you expect it to do. And that's typically done with some unit testing framework, whether it's XUnit, NUnit, or something else. On top of that, you may then look to add in some test coverage metrics so that you can see whether your code coverage is going up or down, depending on whether you're adding in new functionality into your application. And that's a metric that you can use to, over time, make sure that things are progressing the way you want it to. Once you've got all of those things in place, you will typically package up the application. So whether that is wrapping it up as a NuGet package or as a chocolatey package or as a .NET Global tool, or it's a website that you want to deploy somewhere, you need to package that up and put it somewhere. And then once you've got it in a place where you can put it somewhere, ultimately you will publish it. So you'll publish it to NuGet.org or NPM repository, or you'll host it on an Azure website. Wherever it goes, it's part of potentially your overall build workflow. And then contained within all of that, you might want to add in something like static code analysis. So again, as your project is maturing, you want to make sure that the code base is in a good state. So you might want to use something like StyleCop or add in some ROS analyzers so that you know that the build, what you're compiling is exactly the way you want it to be. So the maintenance of that project becomes easier over time. So what I'm describing here is a typical build workflow. Your build workflow might be different, but essentially all of these steps and also potentially some additional steps is what I refer to as the build. And what Cake is it's a build orchestration tool. It is a mechanism that will allow you to stitch all of those different components together in an organized way. So what we saw within that chart, essentially that graph that we drew, we saw that there were some dependencies. We saw that before you could run the unit tests, you have to run the build. Before you run the build, you have to do the restore. So those dependencies within that graph are something that Cake will help to orchestrate. So Cake as a project is open source. It's available on GitHub. It's been around since about 2014. Now, full disclaimer, I am a maintainer of that Cake project. I've been working on it since around late 2015. It is a cross-platform tool, meaning that it will work on Windows, Mac, and Linux. It's also cross-environment. So what I mean by that is you can run Cake locally, or you can run it on your premises and within your organization. You can run it on containers. It'll run pretty much everywhere that you would want it to. It's also cross-service. So what that means is if you want to run it on Azure DevOps, or you want to run it on AppVeyor, you want to run it on Circle CI, you want to run it on TeamCity, you can anywhere that you can run .NET, you can run Cake as well. It's also cross-runtime. So what I mean by that is it has runners for .NET Framework, it has runners for Mono, it has runners for .NET Core, and also .NET Global tools as well. So it'll run cross-runtime. Now, at its heart, Cake is a scripting engine, so we will be writing a Cake script. So what we add on top of that is a C# DSL that allows for ease of execution of certain things that we want to do as part of our build process. So the question that naturally comes up is, well, where can I install Cake from? So Cake as a project has, it's been around for a little while now. So we've gone through some different iterations in terms of .NET. So whether it's full framework .NET, whether it's .NET Core, and now with .NET 5 coming into play. So there's different packages that you can use. But up on NuGet, you will find the Cake project, Cake package, which is the cake.exe. So that will run on .NET Framework and on Mono. There is also a cake.tool. So that's the .NET Global Tool implementation of Cake. If you are still using .NET Core 2, and that's where the cake.core CLR package would come into play, and you could use that. There's also cake.frosting. So what I'm going to be showing here today is the scripting implementation of Cake. But if you prefer to run your builds as a full console application, then that's where cake.frosting would come into play. If you're on Windows and you want to install Cake globally on your machine, then you can absolutely do that with a chocolate package that is cake.portable. If you're on a Mac, and again, you want to have Cake installed globally, then there is a homebrew package that you can use. Or depending on your environment, you can then use, we create a number of Docker containers where you can bring that into your build process with one of those containers. So in terms of getting started with Cake, what we recommend now is making use of the .NET Global Tool version of Cake. That's where we recommend folks get started. So the way that you do that, if you were wanting to add Cake onto a new project, what you would do is you would walk up and you would create a new tool manifest file. And into that tool manifest file, you would then say, I want to install the Cake.NET Global Tool. And then with that in play and that manifest file checked into your repository, you're then pinning that build to a specific version of Cake. So again, that due diligence is then saying, I'm installing a specific version, so I know that that build is going to be repeatable and maintainable and resilient over time. So once you've got all those pieces in play, when you add it to a CI server or when you run it locally, you would run .NET Tool Restore, and then you would run .NET Cake, and that is what will then, that finishes the bootstrapping process, so we're then ready to use Cake as part of our build automation. So what we want to do today is we want to attempt to build something with Cake. So I've got a very simple application that is just a very, very simple .NET class library that gets packaged up into a NuGet package. Got some unit tests for that library, and then we also ship that as a .NET Global Tool. So what I'm going to try to achieve, it's a short demonstration today in terms of time. So I'm going to take that original overall build workflow and I'm going to condense that down into just looking at a few constituent parts. So specifically the 5 that I'm showing here. So with that, I'm going to switch over to a demo. So what I've got here is, this is VS Code. And in here, I have that solution that I spoke about. I have the class library, I have the unit test that is exercising that class library, and then I have the .NET Global Tool that we want to ship. So ultimately, at the end of this, what I want to do is I want to have a full build that will generate those packages ready for me to publish them somewhere. Okay, so to save a little bit of time, what I did prior to this is I've already run those steps I mentioned in that slide. So I've already run the created the tool manifest file, and I've already installed Cake into this project. So if I run .NET Cake here and passing in the info, then I'm going to get some ASCII art, because everyone needs ASCII art in their lives. But what I'm showing here is that we're just using, I am actually using the RC version of Cake. It's the one that we've literally just shipped within the last few days with full support for C#9 as well as .NET 5. So that's what we've got here. So the only thing I need to do to get started with this build process is I need a build.cake file, or a .NET Cake file. You can call it whatever you want. A convention is to call it build.cake. So what I need to do here is, in order to get started with a Cake build, I need an entry point. And typically that comes in the form of a target argument that you would pass into Cake on the command line. So what we're using here is a Cake scripting alias called argument, and it's going to do the hard work of taking that argument from the command line, bringing it in, and making it available within my script. So once I have that, I can run another alias here that is just called run target. So what this is doing is it's setting up Cake so that we can run some tasks. Now I have control over which tasks that I can run, and what I'm going to do now is I'm going to start stubbing out that graph, that dependency graph that we spoke about before. So the way I'm going to do that is I'm going to start creating some tasks here. So I'm just going to give them some names. I'm just going to represent them as strings. So the first task that I'm going to look at is a clean task. Then I want to, I'm just going to stub out, I'm going to put placeholders in for all of the tasks essentially. So I've got a restore task. Then I'm going to have a, my build task was next. So I'm going to put that in. Then I'm going to have my test task, which was the unit test task. And then the final one that was in the chart that we showed was the package task. Now, what I did up here on line 1 was I said that if there wasn't a argument passed at the command line when I invoked cake, then I want to run the default target. So that wasn't shown in the graph that I showed before, but I'm going to add this in, and this is going to be my top level default task. So if a target isn't specified, that's the one that's going to be executed. So to get this started, what I need to do is I need to start putting in play those dependencies between each of these tasks. So the way I can do that is I can go down here and I can say is dependent on, and I can give that the name of the task that I want to execute. Now, this is a string representation of that task. Now, this is essentially a magic string. It's not ideal sometimes. So certainly what you can do is if you want to create a named version of a task, I can just create a variable here and say that this is the package task. So I can replace that down here with just, if I can learn how to type, I can create that as package task. So what I'm doing there is I'm creating a dependency between that default task and that package task. So at the minute, we're not actually doing anything. We're not doing anything as part of this cake script. I'm just setting the foundations there to allow us to start executing tasks. So if I walk up here and I say run cake again, what it's going to do is I haven't provided a target argument, so it's going to run cake with the default target. And because of this dependency here, I can see that I'm running the default task and I'm also running that package task. So if I just run through and create the rest of these dependencies, so I'm going to say is dependent on and test. Again, I could make them variables rather than using strings, but I'll just carry on with this at the minute. So I'm going to say the test task is going to be dependent on the build task. And the build task is actually dependent on two things. So I want to be able to say is dependent on here. I want to say that that's dependent on my clean. And I want to say is dependent on my restore. So with all of those things in play, we've essentially created that full dependency graph. It's actually known as a directed acyclical graph, if you want to get the technical term. But what Cake's going to do is it's going to ensure that it's going to execute each of those tasks exactly once, and it's going to execute them in the order that the dependency describes. So if I run .NET Cake again, it's not doing anything yet. It's just laying the groundwork for having all of these run in order. And I've clearly got a error that I have is dependent on task build, which does not exist. I have a typo. I've got a double L. I saw it. So obviously, this is a strongly typed language. So when you get an error, there is an error in your code. This particular error would have been highlighted by the fact if I had used my tasks definition for each one. But right now, what I'm doing is I'm going to show if I run now, the default task is dependent on package is dependent on test. So I'm now running all of those tasks in order. If there was a specific task that I wanted to run, let's say I wanted to run the test task again and again, because I'm iterating over my unit test and I want to run just the test task, then I can specify that as a target argument. And now I'm no longer running a package. I'm going to run just the test and all of its dependencies. But if I wanted to run literally just the test task without running any of its dependencies, I can pass in another argument that is the exclusive argument. And what that will do is it will run just the test task and none of its dependencies. So what I'm showing here is that the Cake allows for different entry points. So depending on what your CI system looks like or what your local build process is like, you may want to be able to run one task, or if you're doing a build process, or you might want to separate that as have a separate deploy pipeline. You can absolutely do that within the same Cake script. So now that I've got all of these pieces in play, I want to start actually doing some work. So what I'm going to do here is Cake provides another method that I can call, which is the does method. And that's just a lambda where I can actually do some work. So what I'm doing here is I want, and this is my restore task. I actually want to run .NET restore at the command line, and I want to pass in the solution file so that it can restore all the required packages. So what I'm going to want to do is I'm going to want to create a solution folder so that I can instruct Cake on where that locates. I could do this in line, but this is the kind of thing that I might want to use in multiple places. So I'll define it as a variable. So in my restore task, I can then do .NET Core. And what we'll see here is we've got full IntelliSense. Although it's C# is a although Cake is a C# DSL, within the VS Code extension, we've got full support for IntelliSense through OmniSharp, which is also running within VS Code. So what I can do here is I can use the .NET Core restore alias, so I can find out what needs to be done here. So it needs the root folder that where it wants to do the restore on. So that's just going to be my solution folder. So I'm going to give it that, and I'm going to save that. So if I go back down to the command line here and I say run my restore task, what we should actually find now is that the restore task will run. It doesn't have any dependencies, so it's going to run by itself. But what it will now do is it will invoke .NET at the command line, and it's going to run .NET restore. So we're seeing that all the packages, all the projects are up to date, and so there was nothing for it to restore. Obviously, I did this just before the demo, so those weren't required to actually do anything. But it did actually attempt it. So going down the tree a little bit, we can then create a does method for the build task. So I'm going to create a lambda here again. In here, I'm going to look to do something else. So there was a .NET Core restore alias. So it kind of goes without saying that there's a .NET Core build alias that we can run as well. So what it needs is it needs the solution folder as well for what it's going to be building. But what I want to be able to do here is I want to be able to control more granular the things that .NET build command is actually going to be doing. So what I can use here is the .NET Core build settings class. So this is a strongly typed class that allows us to set the different parameters that you would ultimately have to know what they are on the command line. So the one that I'm interested in just now is the no restore option. So I'm going to set that to true. The reason I'm going to set that to true is because within this build workflow that I'm creating here, I've already done the restore. So by default, running .NET build will actually do a restore for us as well. But we actually don't want it to do that because we've taken ownership of that. We own that part of the build pipeline, or the build workflow rather, so we don't want it to happen here. So I'm going to go ahead and save that, and I'm going to run the build task this time. The build task has a dependency on restore, so that will be invoked as part of this process. So what we'll see happen is that the clean, we're not doing anything in the clean yet, but we will run the restore again, and we will run the build. So we'll see the build complete. This is obviously a demo project, so there's no problems with it. It will build, and it will build successfully. So we're starting to stub out this process now. We're getting a full build workflow starting to be created. So I can go one step further. So the next one after that was the test project. So I'm just going to borrow the code from above, because again, it stands to reason that if there is a .NET Core build, then there will be a .NET Core test, and there will be a .NET Core test settings class as well. So in the same way that we did before, I want to augment this process slightly. So I want to use the no build option, because for the same reason that I didn't want to run the restore as part of my build task, I also don't want to run the build as part of the test task, because I've owned that process all the way through the build. So I'm going to change this to be the test task. Again, just to labor the point a little bit, that dependency graph is going to be met. Test is dependent on build is dependent on store and restore and clean. So each of those are going to be done each time that I run the build. So again, it's making sure that we've got a repeatable, reliable, and resilient build that we can then ultimately put into our source control, because this build.cake file will just live within your source control, and it will evolve over time as you need to add more functionality to it. So what we see here in the output is that we ran all of our unit tests, all of them passed, so we're ready to move on to the next stage. So the next stage was the packaging of this application. So again, I'm just going to borrow the what we did before, just for the sake of time, because again, there's a .NET Core test task alias, but there is a .NET Core pack, and there is a .NET Core pack settings. So again, same reasoning before. Don't want to do the store, don't want to do the build, but I also want to control where those packages are created. So I can go back up to the top here, and I can say I'm going to create an output folder. And then in there, I'm just going to call this artifacts. I'm going to use this output folder as a new property within the .NET Core pack settings. So I'm going to set the output directory is going to be to my output folder. With that in play, I'll just kick that off, and then we can start talking about what it's doing. So we're going to run package, and I'm going to minimize this so we can see it. I'm changing the entry point to be my package task at that point. So it's going to do that full dependency tree is going to be met, clean, restore, build, test, etc. But what we'll see happen differently this time around is it will create an artifacts folder, and that artifacts folder will be populated with the NuGet package that is our class library, and it's also going to be populated with the .NET Global Tool package that we could then push up to NuGet.org so that people could install it when they need it. So what we'll see is it's created an artifacts folder, and it's put those two nupkegs in there, which is exactly what we wanted to do. However, the output directory here was created by virtue of the fact that .NET Core Pack happened to create that folder. But in order to have a fully reliable build, we need to own that as part of our workflow as well. So what I'm going to do is I'm going to go back and I'm going to populate this task that we left up here, which is the clean task. So in here, I'm going to just create another function. And in here, I'm going to use another one of the cake aliases, which is the clean directory alias. So what I can do here is I can pass in a path to a folder that I want to have cleaned as part of my build process. So I'm just going to go ahead and save that, and I'm going to change this to be the clean task down here. Because what this is going to do is there's two kind of inherent operations within the clean directory alias. The first is that it will clean the @repack folder. So every time it runs, it will empty that folder. But more importantly is if I go ahead and delete it and I run the clean target again, then it's also going to ensure that that folder actually exists. So rather than relying on the .NET Core Pack command to actually create the artifacts folder, we've owned that as part of our overall build workflow. So with that done, the final thing to do really is just remove the target that we were invoking there and just invoke the default target. And what we'll see is for our entire build workflow happening again. It runs the clean, it runs the restore, the build, the test, and the package. So hopefully what you can see here is with very little work, I was able to create a build script. I was able to invoke it using the command line, and then I was able to step through that build workflow to have everything work for me. Now, one thing that is nice to be able to do when you're writing C# is nice to be able to debug your code. And that's exact same thing within a C# build automation tool. I want to be able to debug it to make sure that things are working the way that I want it to. So all I've done here is I've just put a breakpoint on my clean task here. And I'm just going to hit F5 within Visual Studio Code. So what that's going to do is it's going to launch Cake in a debuggable mode, which means I can step into the code. So what we should see is that this breakpoint will be hit in this clean directory because it's the first thing that gets done as part of the build process. And then here I've got the full sort of debug experience within Visual Studio Code. I can set watches, I can see what variables are set. So that allows me to figure out what's going on with a build, then to be able to see what's going on. So in terms of demo, that was all I had. But I'm going to jump back to my slides here and say that just a final couple of points with regard to extending Cake. So what I've shown in this demo is a very, very quick overview of the built-in features, the built-in aliases that exist within Cake. But if you wanted to have additional functionality, then we have a community of folks who have added additional aliases into Cake. One of those, for example, is cake.twitter. If you wanted to send a tweet when your publishing cycle is finished, you can absolutely do that, but with using the add-in preprocessor directive. So that will bring in the cake.twitter package, again, pinned to a specific version, so you have a repeatable, maintainable build. But that will allow you to have another alias that is send tweet. You can also extend Cake in the sense of creating reusable scripts. So I created that build.cake file there. But if I found myself doing the same thing over and over and over again, I can create a collection of cake scripts and then package them up as a NuGet package. And that's what we've done here within cake.recipe. Cake.recipe is a very opinionated set of build scripts, but it can be reused over multiple projects. Cake.recipe is actually used across over 100 different add-ins in the Cake Contrib GitHub organization. But it's the same build running multiple places, but if we need to update it, we update it once and then push out a new version, and then we pull that into those projects for them to build. The final one is modules. So pretty much everything in Cake is written in such a way that it is using dependency injection. So if there's something in there that you didn't like or you wanted to augment slightly, you can absolutely change that through the creation of a module. So if you wanted to change how Cake does logging, you can change that with by creating a module that interfaces with that. This particular one that I'm showing here is the cake.npm module. So if you wanted to install a tool using the npm package manager, then you can absolutely do that in a consistent way that we install tools otherwise with Cake. So with that, I'm going to say thanks for joining. I wanted to make sure to leave a couple of minutes for questions at the end there. So I'm going to hand back to Layla to see if there are any questions. If you do need to reach out to me, I'm pretty much Get13 everywhere on the internet. So reach out to me on Twitter and GitHub, and I'll answer your questions from there.
That was great, Gary. Thank you so much. I've not seen Cake in action before, so it was really interesting. We have had so many questions. I don't think we're going to get through all of them, but okay. Let's start. Oh, they've all shuffled around. I've lost them. So people want to know where your slides are and your library. I take it you could share that on Twitter for us.
I can definitely do that. Yeah, I've got a GitHub repo that has both of those things in it. Yeah.
Perfect. Let's have a look at this one. Which .NET versions are now supported? If .NET 4.8 is not supported, how to use Cake Build within it?
So there's a couple of aspects there, so I just want to make sure that we're talking about the same thing. So the version of .NET that you use to run Cake isn't contingent on what you're actually trying to build. So if you're trying to build a .NET 5 project or a .NET 4.8 project, you don't have to use the same .NET framework version to actually run Cake. Cake could still be running an older version of the framework, but you can still orchestrate the execution of the specific versions of MS Build that you needed to for your project. So they're not inherently coupled. It kind of makes sense to have them both the same, but they don't need to be. So the answer is pretty much anything that you can do within Cake.
Great. So this is an interesting one. Why Cake instead of automated builds with TFS or Team Foundation Services?
Server? Yep. So that's a great question. It's a good chance. It's a great question. I mean, the main benefit of using something like Cake, or I mean, there are other systems out there. Cake is just one of them. It's the one that I would obviously prefer that you use because I'm a maintainer of the project. But the benefit of these projects is that you're not then coupling yourself. You're not getting vendor lock-in to something like TFS or Azure DevOps or TeamCity or whatever. So you're writing it in a way that the build automation goes with the repository. So you can run the same build locally as you run on TeamCity. And if for some reason you then change from TeamCity to another hosting platform, you have the opportunity to make that switch without having to rebuild everything in another way of doing things. So when you run a Cake build in Azure DevOps, it's a one-liner. It's run Cake. You do the exact same thing in TeamCity. It's a one-liner, run Cake. So that's kind of the main reason for doing that.
That's great. Well, there are a lot of questions for you to go and answer now on Twitter, Gary, because there's a lot. Thank you so much. That was a really good overview, and it's definitely made me want to go and see if I can have a play and figure some stuff out. I'm not very good at that type of stuff, so automating it would be really helpful. So yeah, thank you so much for spending some time with us, and have a great rest of your day.
Same to you. Thank you for having me. Bye-bye.
Cheerio. Bye. So folks, that is the end of my hosting session. It has been a great pleasure to spend my morning with you all, and to take over from me is the fabulous Jamie Singleton, who is joining us. You're in New York, aren't you, Jamie?
I am in New York, yes. It's a bit rainy here today, but that's okay. We're still enjoying it.
Yeah, we're a bit grey. There's a bit of blue sky. I might go for a walk now, but Everyone's been great today, so you are going to have a fabulous time. And I'm going to hand over to you. Have a great day.
Awesome. Thank you so much, Layla.
Bye.
Bye. Woohoo! Hello, everybody. Thank you so much for joining us here today. Good morning, good evening, good night, wherever you're joining us from. We appreciate you taking that time to spend it here with us today. Without further delay, I would love to get our next presenter up and going. Can I get David Destrol to... Hello, David. How's it going?
Oh, pretty good. It's rainy here in North Carolina as well. So.
Oh, okay. So similar weather.
Yeah.
Perfect. Well, today we're going to talk about language server protocol in .NET 5.
Yep.
So I will let you take it away.
Cool. Yeah, so today I'm going to be talking about the language server protocol in .NET 5. Sort of the back history of why I'm talking about this and everything else is the OmniSharp project. So that was sort of my entry into the open source space, and the language server protocol in VS Code sort of evolved from their workings of TypeScript and the C# servers that they were interacting with to build their IntelliSense. The way I like to look at OmniSharp and the language server protocol really is it's whatever language you want in a box. So OmniSharp is C# in a box, more or less like you put Visual Studio in a place and put an API around it. Originally it was an HTTP server. Today it uses what we call standard input and standard output. I like to call it the poor man's socket because you're dealing with, the console in, console out. But there's other options there as well, named pipes and sockets and so on. Today, VS Code uses standard input output. We're slowly moving towards getting that to language server protocol. That's sort of my goal to get it there. We get a bunch of wins from that. It does support language server protocol today. It supports both the what we call the OmniSharp protocol and language server for other editors. And those other editors are things like Vim, Emacs, anything else that you'd want to be able to consume OmniSharp with. I remember building a language server protocol for Eclipse Shay, which was .NET running. It was like I can't remember the name of the system. It's one of the new Eclipse versions. So it was running Java, but it was using a language server protocol to talk to OmniSharp. And so what is the language server protocol? It's very similar. As I was saying earlier, it's an evolution of those servers. It can be written in any language because you just have to deal with whatever the protocol is. You're only dealing with consumers and producers of that data. But the real value is I can write my language server once, and then it can work in VS Code, Visual Studio, Atom, Emacs, Vim, IntelliJ, right? All these other different editors. So it opens up the avenue for anyone to be able to use your language and use your code. And this doesn't necessarily need to be like C# or VB or any of the standard .NET languages. You may even have a custom DSL that you've built for your company, and maybe that using something like this, you can give other developers or even consumers a better experience. And one of the nice things that the protocol has is progressive enhancement. And in the web, we have progressive enhancement in terms of where, that button has a hover because the browser supports hover. It's a very similar sort of aspect. So if your language server protocol implements completions or IntelliSense, as we're used to calling it, then as long as the client supports it, anyone can then get IntelliSense. But if they don't support those items, then it just doesn't do anything. And that's okay because the client only supports what it needs to support. And so part of this process, I've sat down and worked on creating a C# library that is as close that implements the protocol, but tries to bring it into the C# way of doing things. Right? .NET, we have at least with .NET Core, we have Microsoft extensions for logging, configuration, options, all those kind of things, dependency injection. So adopting those principles, creating a library that can feel very much like just building any kind of .NET application today, or a .NET console app allows us to do that. As well as we have internally built up a client. I like to say it's not really a client, but it implements the client protocol, which is great because now you can create unit tests that are integration tests, very similar to how ASP.NET Core has a test server. So you can actually create a test client that executes your server and does the behaviors that you're expecting. You could create your own IDE. I'm not really recommending that. But the goal is the library does all the heavy lifting for you. You don't have to worry about doing too much. It's also extensible. So language server protocol does define extension points. And so we also support, being able to do whatever you need to do within your server. Obviously, if you extend the server and do a bunch of special things, unless the client understands what that special thing is, they're not going to be able to see it. But that's okay. You could have better experience in your VS Code extension, but someone could still pick it up and use it in Emacs if they felt like it. You can also override the handlers as well. So we're doing that. We also have lifecycle hooks. So if the library is doing something that you don't want, or you want to override the behaviors, you can also do that as well. So we got integrations. As I was saying, you can do the integration testing, which is really great because you can validate a server or a client if you're building an IDE. And you can also do in-process and out-of-process testing. And so as I was saying, Microsoft extensions, you can inject a logger into your handler. And then what it'll do is it'll pipe those logs over the language server protocol's log method. And then they show up in Visual Studio or in Visual Studio Code or however the editor has it. Configuration is the same way. If you're new to .NET Core, configuration is the new way of configuring your data over Configuration Manager. And so the protocol defines configuration on the client that can be provided to the user. And I'll sort of go over this in my demo here in just a moment, as well as strongly typed options. So being able to take that configuration and transform it into something that's useful for you as a .NET developer to consume. And let's talk about configuration. So one other point is just consumers. So OmniSharp Roslyn is as well. But actually, the library's been adopted by several Microsoft teams. The PowerShell extension has replaced their custom language server protocol with C# language server protocol, which is cool. And so I'm supporting those guys as well. Azure's new project Bicep, which I think there was a couple talks on earlier in the week, is also making use of it for their editor IntelliSense, and Razor language server as well. So that one's actually shipping in Visual Studio and Visual Studio Code, and so that language server is actually based off of our basic pieces. And so I guess we will now jump over to the demo. All right, and so I just have some source code here. I've built most of it just because I don't know if I could live code this in enough time to sort of stay within the bounds of this talk. But basically, we're just a .NET program. And I just have, console logs in here just for my sanity when I'm checking things, make sure it works. But in reality, it's just calling language server from, and we configure our server. And the configure server part is the part that's interesting. So your input and your output, these methods, doing the wrong thing, take both a stream or a pipe. Pipe is the new intrinsic in .NET 3.1 or 2. I can't remember what version it came in. That's very similar to a stream. So you can. We support bringing in use the pipe reader or just a stream. As long as there's an input stream or output stream, it doesn't matter where that comes from. It can come in the library. So we sort of dictate for consumers of the library itself that you need to figure out what is your transport going to be. It could be WebSockets. Could be doing stuff in the browser. There's some really interesting stuff going on there. Don't have a demo of that today, but there's been a bunch of cool stuff, especially you look at GitHub code spaces. But this is, we got our configure logging. So we're just going to add our language server protocol logging to that, configure our services, and we'll come back to this in just a moment. And then what configuration sections we want. This is how the configuration section or the configuration system is configured. And so we're just going to go to our code over here. So I have it running as an extension host in VS Code, just for demo purposes. As I was talking about logging, we can go here and you can actually see this is log. I mean, it doesn't make a whole lot of sense, but these are logs coming from the server. So it was processing a configuration request. This is just for diagnostic information. I have the logging turned up to 10. So we'll get that out of the way. So right now you can see when I'm making a server for INI or NIN protocols. I mean, I'm not a huge Nine Inch Nails fan, but I figured it was appropriate just to pick something fun. And right now, nothing's going on. We got like the standard VS Code experience. There's no hover or anything like that. So let's try to fix that a little bit. So first steps first, and I'm trying to actually type on the other window on the other screen, which is not actually useful, is the text document store. So this is where the heavy lifting comes in, and this is sort of outside of the scope of the language server protocol, and that's actually parsing the content and producing meaningful data about it. If you have like a DSL that you built today, you might already have some of these things in place for parsing and finding out what tokens are, all those kind of things that you would expect. And when I talk about these things, if I'm talking over your head, don't worry about it. I'm not really too into the huge parser stuff. I'm not a traditional .NET parsing programmer or a computer scientist, but just talking through the pieces. So this just implements the part of the protocol that's like, oh, I've opened a document, I've changed a document, those kind of text changes coming through. The real hard stuff is in the parser. So it's very trivial. This stuff is on GitHub. Feel free to take a look at it. But this is just going through to find things like comments and where section headers start, and we're actually doing diagnostics. So if the section hasn't closed, we'll say the key is not complete, and we'll sort of show that here in the editor in a moment. If you have a key without a value, or if you have a duplicate key, for example, so, these are the kind of things you might want to have pop up. And these don't have to necessarily be done in line with the parser. This was just a convenience thing. So we'll come back here, we'll save the store, and we'll go back here. So in just a moment as it restarts, now we've got a couple things. We got this little info, which is remove leading white space, and we have this thing about there's a duplicate key. So I could duplicate that a bunch, and we're still going to get diagnostics. And we go down to VS Code. And it's going to show us, duplicate key, and I can lower this down. You can click on it, it takes you there. And that's all just VS Code knows how to do the protocol. The protocol just says, here's the information. And then the client puts it in whatever place is native for the editor. So we'll take those codes out. That gives us some extra data there. And now, well, what if I wanted to fix this? Right? There's no code actions or anything like that right now, but what if there were? And we'll take a look at the implementation as provider here real quick, because it's really not super complicated. So the protocol defines registration options, and you basically have to tell the client, what are the things I support? Do I support resolving extra data? What's the document I'm working with? And one nice thing about the protocol, the library that I've built up, is that it'll actually do the routing of requests for you properly. So if you support, say for C#, right, you got CS proj files and you have CS files, which is something we still need to add OmniSharp. But if you have both, you can actually add a completion handler for CS files and another completion handler for CS proj files, and you can actually split your logic up so you can just be like, this is just completions for what I need to do in a project file versus, this is completions for C# itself. Supported code actions and stuff. So in here, we're going to go reach out to our store. And so we got full dependency injection. So we injected our text document store right into here. It could be interfaces or other classes. It was just convenience. So we try to get our document. If we don't get a document, then we don't have any IntelliSense. And then we try to find an item at that position. This is just stuff I've built up. This document is an IN document. And then we check to see if there's white space within the value, right? And if there's white space within the value, we will add that code action. So we'll go in here, we'll make that quick save, and we will wait for the server to restart. We'll come back to the output. You see it has restarted at this point. And so now we have our little light bulbs. You can do Control Dot, or you can click on the light bulb there, and it takes the value out. And we can undo that and leave it back in. And next is, so this one is not supported in VS Code natively yet, or it's supported in VS Code, but it's what they call proposed features. So the protocol is going through the next version. So this is for the next version, but it's cool to add. It's cool to show and cool to add. And so let's actually go take a look at the token provider. So I'm not going to go into the details of tokenization. There's some really interesting logic and math in terms of how they want to transport this data, because this is for tokenizing the document and showing meaningful stuff. So if you're using Visual Studio or even VS Code now, you can, if you have an interface or an enum, they might show up different than a class in terms of the color of the class name and stuff. And so that's what's called semantic tokens, or semantic model. So you get that extra meaning. And so this handler just goes through and does the semantic modeling that you're expecting, or the semantic tokenization. And this can be however you want to do it. And then the library will make sure to transport the minimum amount of data possible. If you want to yourself create it so that it can do the minimum amount of tokenization possible based on the recent changes, there's more stuff you have to dive into. But the interesting part is now we have some different colors. And we can do whatever kind of text we want. And in this model, the first 5 characters or so actually sort of dictates the color. So that's just the way that it tokenizes it here. But one interesting thing is if you use ASP.NET Core or .NET Core, there's this options monitor here that I've injected for my INI configuration. So we can actually go out here to options monitor, and it has a current value. It's got this unchanged thing. And so what does that mean for me as a consumer? Well, it means we've taken the configuration from the client and we've bound it to the server, but using the .NET pieces. So you don't have to worry about managing the configuration and parsing the JSON and all that kind of stuff. You just have to interact with this options monitor. And so what we've done here is we store the current state. And so we're going to do a rainbow tokenization. So we're just going to do a random tokenization essentially. And so whenever the state swaps, we're going to send this request to the server, or it's from the server to the client. And the client understands this as being a refresh param. And this, if you hover over this for a moment, it says it's obsolete, but it's just because it's a proposed feature. So we mark it with that so that you know not to use it if you're doing something that's going to production potentially. And so this tells the client to just go retokenize and get the tokens back and render those back. So what I can actually do is in VS Code, you have your settings JSON. And so I just have it open here to the side, which is why it's been there this whole time. And so if I save that, now it's gone to this more sort of rainbow effect where each item is getting a different token potentially, just based on it's the next token in line. So I mean, I can duplicate that, and now it's going to be more rainbows everywhere. Who doesn't like rainbows? I did the same thing. I can turn that off. And the server has done all of the processing for dealing with the change of coming through for you. It's just said, here you go. Now, I mean, it wouldn't really be a useful server without something like completion, right? So let's turn completion, and we'll turn hover on as well. So I can take some questions here in a moment. So we'll come through, we'll take a look. Server's restarted. And so now I can come in here and I've got some great values. I'm using a fun little library called Bogus. It's more for unit testing, but it lets you generate random data. And so in this case, I'm just using it to generate random data based on the key. So it's consistent within the value of the key. And so I can pick that up from IntelliSense. And now I also have hover, so it tells me what the key is, what the value is, what the section it's from is. I go to the section. But now we can sort of bump it up a little bit. We got code lens. We'll do that. And so when this loads up, you should see it pop up fairly soon. Right, and so now the code lens is telling us you got 3 values here, you got 5 values here. All right, if I go duplicate this, and I add another value there, it says, oh, you got 4. And I just went to search because I'm smart. I do the same thing here, and so on and so on. So now you have code lens. Now I'm not demoing that code lens can actually link off to things, but code lens can do like find references, so you get to list all the references, and there's a way to actually present the references to the user. I didn't dive into that for this. And then let's just do the other ones. So we got folding range and we got outline. Actually, we'll do folding range in a second. And so that starts up. So now, actually, if you look over here on the side of VS Code, I'll close this so we can get some more looking at it. We've now implemented the outline provider, or the outline document symbol provider. And so this gives you the ability to say, what are the symbols in this document? And so we'll come back here and you can see here's the keys, the values, all that stuff. So VS Code knows how to present this, so it just presents it. As long as it's implemented. If it's not implemented, it doesn't do anything. Another nice thing is this server supports the ability to use NIN files. Again, just to keep up with that theme. This doesn't have the INI text parsing turned on, but because we have the semantic tokens, it still does tokenize some stuff, which is quite nice. And then we'll do the final two. So I'll turn on folding range while that starts up. Then VS Code has this idea of what they call selection range, which Visual Studio has too. Some ReSharper and other products do as well. But basically, you can actually inform the editor of what values it should expand to. So by default, it will do the current word, but then the next will be like, oh, I'm going to do the whole item. And there's actually a bug in here. You can see where it's actually not covering the E. I just didn't fix that. So how I have it set up is it's going to highlight the whole value, and then it's going to highlight the value with the key, and then it's going to highlight the entire section. And it doesn't really matter where you do it. If I'm in the middle here, it'll still highlight that whole key, and then it'll highlight the entire section as well. And then finally, the folding. All right, so now we have code folding here. So I told it where I want the folds to be. I want them to be on a section. So it'll fold that for you. And then finally, we're going to actually just close this. And this all ports over to Visual Studio as well. So I'm just going to start up my Visual Studio extension real quick. And Visual Studio doesn't support all the features, or there are some bugs in my implementation, to be fair. I'll pull it over here as soon as it starts up. So this is an extension using a language server protocol in Visual Studio. So I already have the folder open. I'm just going to open that same sample folder we were just working with. Sorry, emergency alert going off in my house. It's raining out. I apologize. There's nothing we can do. I'll give this a moment to finish loading. Hopefully my computer, it's Visual Studio. We all love it. We all know it's Visual Studio. You can do it. I guess it got scared by the emergency alert. All right, so now it doesn't do the semantic tokens, but we do get the folding. We do get things like IntelliSense. So all those things are there. And now I guess I'm ready for questions. Oh, I can do one more thing with my slides actually really quick. So I'll present that. One other thing is there's a debug adapter protocol Visual Studio Code implements. We've built this up for the PowerShell team, as well as any additional links that you may or may not have. So link to the repository. Documentation is still something that I really need to work on, so I've been doing that. And then the 2 specification documents are there as well. So, all right. Are there any questions? There's Jamie.
Hey, David. Excellent session. That was amazing. I loved all of the singletons and all of those animations. The bot animations were really great. So we have one question that I'd like to bring up. So from Bitbunk, does the Visual Studio Classic use C# LSP for the C# code editor?
It does not. So the C# editor in Visual Studio is custom homebrewed thing that's been not homebrewed, but it's the same thing that's been in Visual Studio for years. Yeah. Okay,
so nothing new.
Yeah.
And then we have one other question from Coder Goblin. Great talk. I agree. Is there a way that they can get a list of the shortcuts you were using in VS Code?
That's always a great question. I have a few custom ones. My key blanks. I can't remember what it is.
Well, maybe we could share a few of those out on Twitter.
Yeah, I can certainly do that. I can put some out. I mean, I have some that have sort of fallen over for over time. So this one actually came from Adam, Control /, those kind of things. Yeah, I've customized it a little bit, so it's more like a mash of Adam, Visual Studio, and VS Code. So that's just how I've been doing things. I tried to make sure that at least the code bindings are showing up in VS Code so people can see I was actually doing things.
It's a real demo, people.
Yeah.
Well, amazing. I think that might have been all of the questions that we have.
No problem.
But thank you so much for joining us here today. I'm glad that there was no emergency that happened and that we moved forward. Thank you so much, David, for your time. Thanks, everybody who joined us here. Let's go ahead and go to a video before we switch over to our next presenter.
Thank you. Have a great day.
Hey there, I hope you're having an amazing .NET Conf 2020. I want to take a quick commercial break, just really quick, to tell you about an amazing new learning opportunity over at Microsoft Learn. Microsoft Learn is an amazing way to get started with interactive learning modules on any software development topic. Now, the team has come together to build out the Building .NET Applications with C# Introductory Module Learning Path. Now, let me tell you what that looks like. Over here at aka.ms/.NET Intro, you'll find the Build .NET Applications with C# Learning Path. This learning path consists of 6 different brand new modules. For example, here, we'll go through and write your very first C# code, get an introduction to .NET, learn about dependencies, the .NET debugger, working with files and directories, and then finish it by building a web API with ASP.NET Core. Now, these are really cool. Check this out. Every single module has different exercises and steps inside of them for you to complete and actually earn different points that you can compete in the .NET Learning Challenge. And this is nice because you can use common code editors like VS Code, and for some of the modules, write code directly in the browser. So for example, here on the Learn C#, I'm learning about system writeline and console writeline. So I can just write console.writeline here, fill in my line, and hit run. And it'll automatically output it right there. What? That's amazing. You can learn directly in the browser. Now, this brand new introductory learning path is great for anyone that wants to get started with .NET. Just go to aka.ms/.NET Intro to learn more and have an amazing .NET Conf.
Excellent. Yeah, so go on over to Microsoft Learn and get some updates on the new .NET content that we have over there. So I think we have just a couple more minutes before we walk into our next presentation, but we have tons of content that we want to share. And we're using a tag board, so please feel free to ask questions. If your question gets asked on camera, then we actually give you a gift card code to go to the .NET Foundation store and get some really fun goodies that we have over there. So make sure to ask your questions with the hashtag .NET Conf. Let's go to our next session. We have Carol Rennie Logan here joining us here today. Hi, Carol.
Hi, how are you?
Good, how are you?
Good, thank you.
Good. Okay, so we're going to talk about getting started with Blazor. Yeah? Okay, well, I know you have a lot to cover, so we'll just get right to it.
Awesome, thank you. Great, so we'll just get started. I'm Carol. I'm a development team lead. I'm a .NET developer at Equator, and I'm in Glasgow, in Scotland, in case you can't tell from the accent. And you can find me on Twitter or on GitHub or on my own blog there. And what we're going to do is we're going to go through how we can create a project using Blazor. So we're going to go through history as a .NET developer, how maybe our stack's changed over the last few years. We're going to go into an introduction to Blazor, and then the difference between Blazor WebAssembly and Blazor Server, and then we're actually going to get started on creating that project. So my history with .NET started about MVC. I know for some people this will be, actually it'll be web forms, then it will be MVC, and then so on. But I started with .NET about 7 years ago, so I was lucky, I guess, to jump straight into MVC. But what I've noticed over the last few years is a lot more of my role as a backend developer in .NET has been creating APIs using .NET and Web API that are then consumed with single page applications like Angular and React. And I'm sure that that's a pattern that a lot of people have seen over the last few years since single page applications have become popular and the kind of features that they allow. So something that has really caught my interest as a .NET developer has been Blazor, because it seems to, at least, give us the best of both worlds, where we can write our .NET code and still have that single page application functionality. So what is Blazor? Blazor is an HTML framework, kind of along the same vein as Angular and React and Vue, and it's used for rendering .NET on the client side using WebAssembly. So the bit that really got me as a .NET developer was this part here. It offers all the benefits of modern front-end frameworks while working entirely in C#. So that entirely in C# bit had me a bit like Drake here. It's like, yes, I don't have to try and keep up with the latest JavaScript framework, and I can do what I know best, and that's write C#, but have that in the browser. So this is from the Blazor docs, and you can see some of the advantages listed here. And the main one for me, as I said, is we can write C# instead of JavaScript. So as much as I joke about I don't need to look at JavaScript anymore, it's more it lets us choose the right tool for the right task. So even in Blazor, you probably will still write some JavaScript, but it means that you can use .NET and C# when you want to, and you can write JavaScript when you want to. And you can leverage the existing .NET ecosystem and .NET libraries. So for me, that's a big one. We all have the libraries that we know, that we trust, and it means that we can use those in our single page applications. If they're written in .NET Standard, it means that we can bring them right over to Blazor and we can use those. We can share logic across the server and the client side. So if it's written in C# and you've already got that code written, then you can write it. You can use it in your Blazor app. And we can kind of have the reliability and the security and the performance that we know that we get from .NET straight into our Blazor app. And it's built on a common set of languages and tools that are stable and easy to use for us as developers as well. So one important question when you're looking at Blazor is it client side or is it server side? There are lots more features coming out, and even on the client side, there's like different hosting strategies and different features that you can add in. But at a very kind of fundamental, simple level, it's kind of client side or it's server side. So on the client side, or WebAssembly Blazor, you may hear it referred to as, we've got our C# code files and our Razor files are compiled into .NET assemblies. And the assemblies and the .NET runtime are downloaded to the browser. And on the client side, that's where the runtime is bootstrapped and it's configured to load your assemblies into the app. So it uses a JavaScript interrupt to handle the DOM manipulation and any of the API calls that we have to make for any of our functionality. And here's a nice diagram. I can't take credit, taking it right from the .NET docs, but they're pretty good. So as you can see, everything here is in the browser. And you've got your Razor components, you've got your .NET code, and you've got WebAssembly all within the browser, and there's kind of dynamic DOM updates happening as and when we need them to. So WebAssembly is something you'll hear a lot when you're looking at Blazor, especially on the client side. And here's a quick description of it. I'll not read the whole thing out to you, but the main thing here, it's a open web standard and supported in modern web browsers without plugins. So it means that we can use .NET straight there in the browser, and WebAssembly is what enables this to happen. And you will hear a lot about the JavaScript interrupt too. So it allows the WebAssembly code to access the full functionality of the browser using JavaScript. And our .NET code is executed via WebAssembly in the browser, and it's using that JavaScript sandbox to allow that to happen. So on the server side, just to have a quick look at the difference between the two, Blazor server side provides support for hosting Razor components on the server of a .NET Core app, and the UI updates are handled using SignalR, which I'll explain a little bit in a second. And the runtime handles sending those UI events from the browser to the server, and it applies the updates as and when they're ready for the components. And again, it uses JavaScript interrupt to allow that communication to happen. So it lets you have the kind of the Blazor single page app type functionality without kind of full page reloads, but it is still actually hitting your server on the back end. So SignalR is ASP.NET SignalR is an open source library that allows that real-time kind of connection to the server and updates of your application to happen instantly. And again, here's a lovely diagram from the .NET docs, and you'll notice the main difference here from the last one is that the browser is kind of off to the side. The DOM's obviously still in the browser there, but the updates to the DOM are happening using SignalR to your server. And what's really good is it's really clever, and it only updates the bits of the DOM that have changed. So it doesn't do a full refresh every time. It doesn't kind of impact performance by trying to render the whole DOM again. It kind of does a diff, and it only updates the bits that have updated and the components that have updated. So we'll jump straight in. And what I want to do is we're actually going to have a look at how do you literally start from the very beginning with Blazor, and what do you get out the box in the Blazor kind of templates in Visual Studio, and how can we build upon that to create some more functionality. So if you want to do it in the command line, there's two options here. You can do .NET New Blazor WASM, which is an abbreviation that you'll see used for WebAssembly, or you can do .NET New Blazor Server. And with either of those, you can, of course, do --help, and you can get some kind of help and information there. But you can also do it through Visual Studio, so you can file new, and you can choose Blazor app there. And what you'll get is you'll actually get the option to do either a Blazor server app or a Blazor WebAssembly app. And within, as I mentioned earlier, there's configurations even between each of those. And for the WebAssembly app, you'll notice that down here, you actually have an option to make that WebAssembly app ASP.NET Core hosted version. And you could also have the option to have progressive web app features. So when you tick that, you get, some service workers, you get some of the functionality that allows for offline applications, for, notifications and that kind of thing to pop up. So there's quite a lot you can get just from these Visual Studio templates. And this is the file structure that you get. So if you do file new in Visual Studio, and this is what it sets up for you. So what I'm going to do is jump out of slides, and we'll jump straight into Visual Studio. So hopefully you all can see that. And as per the screenshot that we just saw, this is what we get. So we have our pages that we'll have a look at soon. We have our shared folder. We have our web root, which is actually, got our CSS and things like that in there. And then we've got a few other bits, and I'll explain how all this works later. But what I'm going to do is show you the application that you get when you create this from scratch Blazor app. So if I do .NET watch, so this will build the app, and it'll set a watch, and it means that it'll launch the app. It will open the browser soon, and it will. I'll put my browser over there, and it will actually watch for any changes that are made, which is cool. So it means we can make changes and have those appear instantly, which is cool. So here's the apps that we get. So hello world is what we're used to seeing when we create a new app. And you'll notice there's this component here where you can take a survey. And we'll go into, we've got our nav here, which shows the different places we can go. And the counter, this is the first bit of functionality we really see, and we can look at the code behind. Where if you click that, you'll see it automatically updates here, but you'll also note that there's no post to the server, any kind of refresh on the page. It's happening dynamically, and it's just updating there. And we also have this one here, fetch data, which in the background you can't see. That loaded super quick, but in the background it's actually doing a bit of logic to go and get that data. Not quite an API call, but to kind of be a mock API call. So that's the application that we're building and that we get out the box in Visual Studio. And I'm going to give you a tour of how we actually build that. So yeah, as I said, here's where we start with. So we've got our program CS, and this is where it all starts. So we have our app it's added here, rootcomponents.app, and we'll have a look at that. And you'll see that this is WebAssembly host builder. So this shows that it's WebAssembly Blazor. And then you can add in any services that you need. So you have your HTTP client. You'll see where we're going to use that later. But here is where you could inject if you have any of your own services that you want to build and add, or any other third-party ones that you want to use. This is where you can make sure that they're included in your application. So this references the app. So let's have a little look here at the app.razor. So this is where it sets up our router, and you can see it's linked to our program CS there. And what it does is it tells us that the default layout is our main layout. So we can have a look in there. It's within our shared folder. And if we jump in here, we can see this is the main layout that we saw earlier. And on that sidebar was the lovely nav that we saw. And this gives us a bit of an introduction to components and how we can add components into our HTML and how we can use those. So this is our nav menu. So if we jump in here to our nav menu, you can see these are the items that we saw earlier. So these link to pages that we have. We have our home page, we have our counter page, and we have our fetch data here. So if I show you here in the pages that we have, so if we even wanted to change this to hello, and I save that there, we can see that in the background, because we've done .NET Watch, what it does is it actually rebuilds and it will update the application. So that's building in the background there. Hopefully that will refresh just now. Yeah, that's just going to load. And it changes to hello. So using .NET Watch means that you can make changes and have them apply instantly in the browser, and it kind of makes the development process a lot quicker. So what we can actually also do, and here's one I made earlier, is I've got a hello.razor, because I'm not very imaginative. So I have added a new page in here. You can see how we do routing. So we do at page hello, and we've got a quick message that says hello. So if we do that there, we build that. And what I want to do is I actually want to add it to the nav, right? So that we can get to it from the application easily. So if you'll notice here that the href goes to your counter, goes to your fetch data, and this one will go to hello. So that's what links the page routing to how you navigate around within your own code. And this will just be what's shown in the nav there. So if I do a build, and we'll see that updating here within the PowerShell window, and then we'll see it refresh here. Perfect. So now it's here within our nav. We can click hello, and there's our new page. So that's how quickly we can, in Blazor, get started, and we can add some new pages. And obviously, we would not just make it say hello, we would make it have some of our own functionality in there. But I wanted to show just how quick it was to get started in adding new pages. So what we'll also do is let's have a look at some of the functionality that was a bit more interesting than just saying hello. Here's the page where we had the increment count. So it said click me, as you know, and when you click the button, you can see you can use the on-click functionality here to then call code. So any of your C# code within a Blazor view is within this @code segment here. And then you'll recognize that this is good old C# that we know. And we can create a method here, increment count, and it, does a plus on that value that we've set up when the page was loaded. So nothing too complex, but I think this is a really good way of showing how you can hook in your .NET code, your C# code, with your markup there. So you can on-click call that backend code, and that is what makes that, we saw it when we were using the app. Let me open that there. We saw that when we were in the counter, that just updates in there. So we could in there decide to say, we want that to be +2 or +3 or whatever, and that would just, all we need to do is build and it will refresh there in the browser. So one that was quite interesting was here in the fetch data. This is the one that kind of doesn't quite go call an API, but it does a mock of it. So you'll see that there is an if here that while the data is loading, because it has to go and get data, we can put code in to make sure that we show something in the component until the expected state that it can then render the data, which is kind of what we've come to expect from single page applications. So maybe a bit more old school would be that the page just didn't load until the data was there. What we can do in Blazor is we can have it kind of have placeholder data there. So yeah, you'll see that there's a table here that's going to show our data, and then when we have the forecasts available, we can loop through them. But the interesting bit is down here. So in the .NET code, in the C# code, we can set up our object. We have our object here, and we can, when the page is, so on initialized async is when the page is loaded, it calls this code. So because this has an await and it goes to get that data from here, it's just from a file, but it might be from a URL. So because there's an await there, that's why we can have that section of code here that's until we have that object, just show loading, and then once the object is available and the await has returned that data, then it can load the data on the screen. So one thing I wanted to show is having my C# object defined here in the class, in the code section isn't something maybe that we want to do all the time. Maybe we want that to be a shared object with the backend or from a library. So we can take that out there. And again, here's one I made earlier. I have set this up. What I've done after watching the keynote and some of the other talks about the new features in C#9 was I've now made that a record, just because I wanted to see how it works. So that's now a record. If I include that in my project and go back to my fetch data.razor, you'll note that that's got little angry lines under it because it doesn't know where to find that object now. So what this shows is we can just do using and then use my new models folder that I've just added to the project and do a little build there, and our angry little lines will hopefully disappear. So now that that's built, yep, that's then gone now. Happy now. That would just built in here, and if we reload our app, our fetch data should still just work as it did. So we've refactored that. We've taken the object now out to a models folder rather than having it right there in our Razor view. but it all just works the same. And it's using some of those new features now. So because you maybe saw in my screenshot when I had, when we were setting up the project, I redone this on Wednesday after .NET 5 came out and after the new version of Visual Studio came out. So this is all using C# 9 and .NET 5. So I was able to use that record, use a record for that object now, and that all worked good. So yeah, so I've now shown how we can use objects from elsewhere. We've shown how we can add new pages and route to those, and generally how we can get started in using Blazor and within Visual Studio, and also using some of the new kind of the .NET Watch functionality. So hopefully that was useful, and you're ready to get started with Blazor, and that will let you know at least how to get the project set up, and then how you can now create some of your own functionality. But what I wanted to do is have a little quick look at what I learned. So I've been kind of looking at Blazor since before it was officially released in the .NET Core version, when it was still in beta. And some of the things that I've learned, like as a .NET developer, it's really quick to get started, because I already know the ecosystem. I already know a lot of the language, obviously, because I'm a C# developer. And even some of the libraries and things like that you might want to use, I already know those. It's not like, back in the day I switched from Java to .NET and I had to learn all the, what library do I use for that, what do I use for that? So at least I know that within the Blazor ecosystem. Updates to the framework were one thing that I had to keep up to date with quite a bit when it was first in beta, and then when it was first released. And it only seems like there's a few changes that are kind of big changes to the .NET 5 version, at least. Although I would recommend going and watching the talks from Wednesday, so that there was some really good detail on things like the CSS and JavaScript isolation for components. That seems like a really important feature, and some of the pre-rendering and some of the performance updates in general are really, really cool. So because it's a new framework, it is constantly updating. So you might find that you do even that getting started the file new project in a few months when you do it again. A few bits might have changed, but that's good, because it means that things are being updated. And it's constantly growing as a framework. The dev community, I think any new framework, I'm sure you'll agree, even if it's the best framework in the world, if there's no community around it, it's not going to survive. And one thing that I think is really awesome, no pun intended, from this example about Blazor, is that there is a really great community there, and Awesome Blazor is a really good example of that. If you go on GitHub, you can see that there are lists and lists and lists of places you can learn Blazor, ways you can use Blazor, and even like some examples of where it's been used in production as well. So I would really, really recommend having a look on there after you've ran through the docs, you've done some tutorials and getting started. I would really, really recommend going on to Awesome Blazor. And from a hosting perspective, there are so many different ways you can host it. And as a .NET developer, some of the cool things for me now are even seeing you can host it like on GitHub pages, because you can host it as a static app, as a single page app, which we're not really used to being able to do with .NET code. So that's really cool. And you can, as usual, in Visual Studio, you can click publish and you can see the different options you have to publish your app. You can put it on Azure, you can put it on Docker. And as I say, you can host it as a static site, so you really can. There's some good examples of how you can, as I say, host it as a GitHub page, and you can. It makes it a lot easier to get started to build, but then also to host it somewhere and to share that with the world. And documentation, a bit like with the dev community point, documentation is so important with a new framework, because to be able to get this far and getting started, I really, really relied on the documentation. And I need to, like the Blazor team, the .NET team, have done a really good job with the documentation, because if it was hard for me to keep up with all the changes to the framework, it must have been for them too. But like it always seems to be up to date. And there's a lot of examples, and there seems to be, as I say, even looking at it, say, a month ago when I was preparing the talk to again this week, there seems to be more changes and even more information on the docs. So it's really, really awesome. And what I'm really interested in is what's next for Blazor. I think some of the things that I've mentioned there and having a look at it, it's really exciting to see what it can do within web apps. But what I'm really interested in is what's next. And some of the things I've read up on, I've not had the chance to play around a lot with, other than some of the PWA stuff, is where else can we use it? And kind of, as you can see from the examples here, a big part of that is making it not just web applications, but onto mobile too. So there's PWA, which is progressive web apps. So you can have web apps that start to have some of that functionality of native apps on mobile. And there's kind of some really good examples of Blazor hybrid, where it's kind of a Blazor app, but within a kind of hybrid solution within a native app. And then there's some kind of Blazor native examples as well, where you can see it kind of running straight on Android or iOS, for example. It's really, really cool. And there are some good examples of that on the docs, or even just that some folks have done some playing around, and they've kind of published what they've found and what they've built. So it's really, really cool. And a big thing for me will be developer adoption of Blazor. That will be what I'm really looking out for next, to see, is it the framework that we should all be jumping to, or when it's the right one for your project? Because it's really important, as I say, around the developer community. Is the support going to be there? Is it going to be a long-term solution that we're going to now be using, rather than always MVC or Web API? Is Blazor what we'll use for new projects? That I think we'll just need to wait and see. But it's been really exciting seeing from the keynotes the other day, and from a lot of the Microsoft talks, and from all these community talks too, seeing the really awesome stuff that people are building and what they're sharing. So for me, this will be the big one, is looking out for developer adoption of Blazor and seeing the cool things that the community builds. And that's it from me. But if you've got any questions, or if you'd like to share the stuff that you're building with Blazor, I'd really, really love to see what other folks are doing too, and to see what's out there.
Amazing. Thank you so much, Carol. That was excellent. We do have a bunch of questions from Twitter. So I don't think we'll be able to get to all of the questions, but I'd love to tap into some of them right now. And then maybe you could potentially go and answer those on Twitter afterwards.
Yeah, definitely.
Okay, great. So let's go ahead and start with one. Andrea P asks, when should I choose Blazor server instead of a Blazor client, and vice versa?
So there was actually a really good talk. I think it was in UK time. I think it was quite early this morning or late last night, but I think it was by Otto. And he discussed the options for server and for WebAssembly, the pros and cons of each, because there are pros and cons of each. So I would really recommend I went and watched it on YouTube this morning, because it was on too late UK time.
Yeah. What was the title of that?
Oh, I can't remember now, but
But it was in the stream.
It was literally called Blazor client side versus server side. So yeah, go and have a look for that on the stream. It's really good too.
Okay, perfect. So let's go to another question. Christian asks, what are the common pitfalls when beginning to develop with Blazor?
Yeah, I think for me, it was just knowing, hopefully what I've helped show, but it's how it all ties together. It's just, it's a little bit different than what we're used to from our MVC app. So just getting to know how everything all works together. And for me, it was things changing quite a bit, but I think that's because I was first looking at it when it was still in beta. So things were changing. So it was like, hey, who moved that thing that used to live over there and now it lives over there?
Yeah, so some common new product type of
yeah.
There. Okay, let's see if we can do one more on here. Which grid component do you personally use in Blazor projects? And this question is by Milan.
So I've not used it beyond just some playing around, to be honest. I've not used it with some real life design requirements or anything like that. I've just been kind of having a play around to get to know it as a framework, as a dev lead, to find out is it what I should use for my next project just yet. So yeah, I've not had to decide which kind of grid components to use. I know that in 30 minutes, my friend Praneema is giving a talk about components in Blazor, so I would have a look at that talk.
Okay, excellent. Let's see if we can squeeze in one more. I remember that I wanted to ask a particular question. Oh, here it is. Okay. So, but Bardaki, let's try to pronounce that. Does Blazor WebAssembly require the application to be hosted somewhere, or can it use as a local application that runs in the browser?
So it can be hosted statically somewhere. So somewhere when you go to your site, it will kind of download everything. But with the PWA features, it can act kind of local, I guess, if we want to call it that, offline. And so it can act more like an app. So if someone's offline, it can just use the local mode, and they can still use your application using the kind of PWA features.
Oh, great. Okay, so I think that's all the time we have for questions. There are a few more on Twitter, though, so if you have some time, maybe you can head on over there and get those answered. We have our next presenter, but I think we need to take a short video break just to make sure that we're all technically on the same page. But thank you so much, Carol. That was amazing. We really appreciate you taking the time to spend it here with us. And this call was recorded, so if you didn't get a chance to watch all of Carol's session, you can go back and watch the stream online.
Awesome. Thanks for having me.
Yeah, of course. Thanks so much, Carol.
Hey friends, I hope you're having a great conference. Today, I want to share with you some cool and exciting stuff that we have been working on. Go over to .NET website and click on the Architecture tab. This portal has many free resources to help you build production-ready .NET apps, including free ebooks on microservices, DevOps, cloud-native apps, serverless, gRPC, Blazor, and so much more. Let's say you're deciding to build a new microservices application. Click on the microservices section here, and you can download a free ebook on microservices architecture. This ebook introduces you to microservices architecture pattern and focuses on designing your application with domain-driven design, containerizing your .NET Core app with Docker, deploying them to Kubernetes, managing resiliency in the cloud, securing .NET app, and so many more relevant patterns that are covered in detail. Additionally, we also wrote a book on architecting cloud-native .NET apps for Azure, which focuses on cloud-native principles and helps you decide what Azure service to choose for a particular scenario. These books are available for you to download as a PDF or read them online from your favorite device. Now, the best part about these guidances is that a reference sample accompanies them. For example, here is eSharp on containers, one of the most famous examples of microservices and cloud-native .NET apps in .NET. It covers a range of concepts like managing distributed data, API gateways, synchronous with asynchronous communications, and so much more. You can run the sample locally using Docker Compose command or refer to the wiki section for more production scenarios like deploying them to AKS. That was about microservices, but there is so much more. Are you looking to port your .NET apps to new and modern workloads? For example, looking for guidelines on porting a legacy ASP.NET Web Forms to Blazor or WCF to gRPC, or migrating your existing .NET apps to cloud? We have a book for that and an accompanying sample for each of them. So don't forget to check them out. Enjoy the rest of the .NET Conf.
Excellent. Welcome to .NET Conf 2020. I am your host, Jamie Singleton. I am so excited to be here. This is my first time hosting, so this is very fun. I believe we have our next presenter, Harish Sharad, and they will be speaking about overview of single file applications in .NET 5. And if I have Sharif, hello, Harish, how are you?
Hello, can you hear me?
I can hear you a little quiet on the volume.
Is it perfect now?
It's getting a little better. I think we should be okay.
Yeah.
Excellent. So we're going to talk about single file applications in .NET 5. I know you have a lot to cover, so I will let you take it away.
Sure. I'm trying to share my screen somehow. Yeah, I think it's here. Yes, perfectly. So, hello everyone, and I think it's good morning, good afternoon, good evening. So people might be from the various regions here who is attending the session. And I'll be talking about the single file applications today, more specifically with the .NET Core 3 as well as the 5. So it will be the overview session wherein basically I will be covering the basic aspects about the single file applications. And I'm Harish Chandra Ukiride, and I'm architect with .NET Technologies and the Azure. So the agenda for today for the session is what is .NET Core. I'll just brief it about like when and how. Then what all .NET versions are there, or .NET Core versions are there, and how those got evolved. And more specifically, in terms of single file applications, when it started and how it is progressing. Then I'll be talking about deployment modes. So what all deployment modes are there, and we will see about that. Then we will see how the single file applications can be created. So a different aspect about it, and the commands which required for the single file applications to be as an output. And we will talk about the project configurations which we need to do in terms of single file applications to be able to generate the applications output in the single file. We will touch base upon the publish, because that is the core for this session, to be able to create the single file applications. And we will have a short demo with the application, and let's see how it turned out with the Visual Studio. And
Chandra, so sorry, is it possible to turn up your mic? We're getting a little bit quiet. We have you turned up all the way on our end, but little trouble hearing you. Sorry to interrupt. You're doing amazing.
Yeah, just write out on the time. Is it okay now?
If you can do it a little higher, that would be great.
Okay, let me try something else then.
That's how you know this is live, everyone. We're doing pretty good considering how many folks we've had online as well. Can't hear you now. Oop. Pardon, folks, we're having a couple of volume difficulties here. We're going to go through this real quick. Oh, okay, now you're muted. Classic. Can we unmute Harish Shrod? Yeah. Can you unmute on your end? There we go. Whoop, when permissions come into play. Oh, there we go.
Okay. Yeah, so sorry everyone about the little disturbances or the technical glitch, I will call it about. And we were on the agenda, like what we'll cover in the today's session. And we will talk about the project configurations. We will talk about the publish, how do we publish the single file applications. And at the end, we will have some time reserved for the Q&A. So let's talk about the .NET Core, what it is. So .NET Core is a free and a cross-platform open source developer platform for the building many different types of applications. And if you can see here, I have highlighted it is the cross-platform for and cross-platform and the free for the developers. So when I say it's a cross-platform, so I would like to stress upon, because we are going to see the single file as an output, and it is more related to the publish and deployment. How do we publish or how do we deploy the .NET applications to the various platforms? So not only the Windows, but it will be like the it will support the web applications, it will support the mobile applications, it will support desktop applications, as well as the microservices, gaming development, machine learning, cloud, and Internet of Things. So it supports the many things, and the base or the core part of the .NET is the cross-platform. Then we will talk about the various versions of the .NET Core when it is started, and what all the different versions we were having for the .NET Core. So the first version of the .NET Core has been introduced in June 2016, wherein we were calling about that version as an .NET Core 1 or 1.x, whatever we can call it about. And it was meant for the open source development, it was the community development, and it was for the cross-platform, so that the .NET applications can be built, can be created and built and deployed on various operating systems, I would say, or mainly like the operating system like Linux and the other applications operating systems than the Windows operating systems. So then with the evolution in August 2017, the .NET Core 2.x came into picture, or it is launched. And with the .NET Core 2.x, the very good feature in terms of deployment has been introduced, and that was the self-contained deployment. So remember, when you deploy the .NET applications to certain platforms, so it needs some runtimes as well. So wherever we deploy the .NET applications, we need some runtime to work the .NET applications on those particular runtime. So in .NET Core 2, we introduced the self-contained deployment, which means whatever we need to run the applications, we club or we self-contain it, and we publish those applications or we deploy those applications. So that was the very nice feature, I would say, is introduced in .NET Core 2. And I will not highlight here which exact version, but .NET Core 2.x. Then in September 2019, the .NET Core 3 has been introduced or has been launched. And with the .NET Core 3, we will have one more great feature for in terms of deployments, and that was the single file applications. So how does the single file applications were working in the .NET Core 3? So it was creating the one file or the single file as an output of the applications, but it was clubbing the dependencies in a separate folder, so that at the runtime it can access those dependencies from the separate folder which is created while the publish or while the deployment. And that was the cutting edge feature introduced in .NET Core 3.x, and it is in 2019. And with the great milestone wherein .NET 5, which is launched a couple of days before, has been introduced a single file application with the in-memory dependencies, which means a lot for the developer, which means a lot for the infrastructure, wherein we have a single file application created, and at the runtime, dependencies will be kept in memory, and from the in-memory dependencies can be accessed by the applications to be able to run the application successfully. So that was about the overall the versions, .NET Core versions, and the topic single file applications, how it is evolved. Self-contained was the first part, then the dependencies with separate folder, and then the application with in-memory dependencies. Just now we launched 2 days before. Then let's touch base on the deployment modes. What all different deployment modes we have with the .NET Core. And first one is the framework dependent deployment, wherein like we need a runtime to be able to run the .NET Core installables or the .NET Core publish files, wherein the framework will be already installed in the machines or the servers, and then there we completely run this application with the deployment mode as a framework dependent or FDD we call it about. Another mode, deployment mode we were having was like self-contained deployment, self-contained deployment or SCD we call it about. Self-contained deployment mode does not use the common .NET Core install on the server. The final application build contains all the app-specific code or all the runtime which is required to be run the application. So it contains everything and its dependencies along with the .NET Core libraries and .NET Core runtime. So it will be created as a package, and that package will be delivered to a server, or package will be deployed to a server. So self-contained came into picture considering the different operating systems. For example, Linux. How do I run the code on the Linux? So we can use this as a feature. Then we have framework dependent executables. So this mode includes from the .NET Core 2.2, and it is exactly same as FDD, but the mode produce the executable that can be run on any target machines. So here also we can do, or we can have the code like similar to the FDD, but it can be run on any type of machines where we will have the framework, and then it will run the code there, then and there. So something about a little intro about the self-contained deployment SCD. And I will not talk about much in this slide as well. The final application and all runtimes, dependencies, and everything is contained, or it will be clubbed with one folder to be able to run on the target. So let's touch base the core of this topic, which is the single file applications, and many people started using the single file applications nowadays, and like single file applications are published and deployed as single file. So it will have only one file and no other dependencies or no a lot of libraries or like dependencies and all those things. The app and its dependencies are included within that file. So everything will be clubbed. When the app is run, the dependencies are loaded directly from that file into the memory. So there is no performance penalty with this approach when combined with the assembly training and ahead of time compilation. Single file apps are smaller and start up quickly. So I touch base here two different aspects. One is the training part, and another one is the ahead of time compilation. So if we use both the features with this, then it will be a little bit lightweight and it will run very quickly. So what is the trimming here? So trimming is nothing but like if you have the dependencies used or the dependencies added in your projects, but you are not using those dependencies. What should we do with those dependencies? So shall we add those dependencies to the final output or the deployables? So no. So trimming will help with that. So we need not to or trimming will not add the unused dependencies or unused references to the final output. .NET Core 3.0 allows you to package an app into a platform-specific single file executables. Here, I would stress upon the platform-specific part, because that was the purpose, or that was the support in the .NET 3. You can generate this executable two ways. Both the methods require a .NET Core 3.0 project or 3.0 project. In .NET 5.0, single file apps are primarily focused on Linux. They can be either framework dependent or self-contained. So it can be either way we can create it. Framework dependent single file apps can be very small, since we are not adding the runtimes and all those things to the single file, by relying on a globally installed .NET runtime. So if you go with the framework dependent, then your files will be very, very small. And if you not go with this framework dependent, it will add some extra runtime and the dependencies. So how do we publish, or what commands we should use to produce a single file apps? So I'll just explain here. So we can use the .NET publish command still to publish your deployables with a flag called -r, and we can provide your runtime version, either whether it is Linux x64 or Windows x64 or anything. Self-contained you can mention as true or false. For this framework dependent you can mention as false, and the publish file, publish single file as true, so that it will create a single file. And if you want to perform self-contained single file app, the assembly trimming and ready to run enabled, so we can do that with the .NET publish command, wherein we can specify the different options as single file as true, and publish trimmed as true, and publish ready to run as true, wherein self-contained also we will have to mention as true. These are the few different configurations for the project file. Output file, I just took one example as exe. .NET target framework should be .NET 5.0, or like whenever the future versions will come, we will have to use that. If you have to enable the single file, you will have to mention publish single file as true. Determine self-contained or the framework dependent. In this case, we will have to mention self-contained at true. Runtime identifier, we will have to mention the runtime identifier, and in example we can see, like, we can mention as Win x64 or any runtime, whatever you want. It can be a portable as well. If you want to enable the publish trimmed, we can enable the publish trim with the true flag, and if you want to publish ready to run, then we can mention as true. So it will be quick and the lightweight. Publish single file. How do we publish the single file applications? So basically, I took this screenshot from the publish area, wherein we can have the folder profile to publish and the target framework. Hit one plus here, like. So different flags. One is publish, produce single file and enable ready to run compilation. Yes, and I think I have covered the slides, but let. Okay, so publish succeeded. Let's go to the publish folder once again.
Touching the pages folder that you see here, the share I'm a freelance developer based in Langley, Berkshire, UK. I do a lot of work around the Umbraco CMS, and I've been an Umbraco MVP for 2 years in running. Non-work me, I read a lot, mainly fiction, and I learn Carnatic music in my spare time as well. That's my Twitter handle, should you wish to connect with me. Straight into the topic, components are building blocks of Blazor apps. They are files with .razor extension. So if you are an MVC developer, you might be really familiar with the syntax that I'll be demoing today. They are basically using Razor code in your files. Your Blazor app could have pages, it could have forms, it could have shared dialogues. All of them are components at the end of the day. Components can be nested. So you can call one component from another component that can be reused. So if you're really clever with your architecture of the components, you can even have a shared library of sorts, which you can share between your various Blazor apps. Component names in Blazor must always start with an uppercase character. If you want to include a component in another component, you can do so by using the name of the component as the HTML tag. So in my case, I've got an example razor called myComponent.razor, which is a component. And as you can see, the name of the component becomes my HTML tag. And that is how I would call my component in a page or in another component. Components compile into partial classes, usually of the same name as the component itself. It's a really tiny bit of knowledge, but this particular tiny bit of knowledge goes a long way, trust me. Today's demo, I have put together a sample repo. It's based on the Blazor WebAssembly model. And I will be talking about a series of things or series of features which components portray. And I'll be basically touching the pages folder that you see here, the shared folder, and the www root time dependent. But I believe the link to my demo repo has been already shared with you. The first thing I would like to discuss about components is routing. If you look at any of the Razor components in the pages folder, you can see something with a page directive right at the top of the file. So this suggests to Blazor that this is a page in your web application, Blazor application. And when these components compile into partial classes, a route attribute gets attached to those partial classes. And this effectively becomes the route template. So you can specify your route template, and that's attached to the route attribute of the partial class. When user requests a URL from your app, the router goes in and tries to find a match for the incoming URL against any of the route templates it's got the knowledge about. So in this case, if the user is requesting parameters, the Razor would find this particular component and return this component. And all this routing magic happens in the root component of the app, which is the app.razor. Here you have the router. It tries to find out what's going on. Does it have a matching route template in its knowledge? If it finds anything, it passes it on to the route view template, and then your component gets rendered to the end user. Any route data is also passed through. If it doesn't find any match, sorry, there's nothing to be displayed. That message gets shown through. The next thing we can talk about is how to include C# code in your components. Components are quite versatile, so it's just not Razor syntax that goes into them. You can add C# code and make it as flexible as you want, make it as interactive as you want. There are two ways of doing it. First one is the code directive way. In the code directive way, your Razor code as well as your C# code will coexist in the same file. Once you are inside the code directive, anything that you can put in the class can be put in the code directive. You can even have multiple code directives, but you can then have fields, you can have methods, your lifecycle events, everything goes inside the code directive. And this is not only for the pages or components with the page directive, you can also have the same thing in a shared component as well. So even with shared component, it's the same kind of structure that follows. You can have your Razor code and then the code directive. The second way to have this, or to have C# code in your components, is by splitting it out into two files. One, the first part of the file would have the Razor code alone. And as you can see, my my component is called code partial class. And it's the same exact code that I have got in my code directive demo here, except that I've changed the heading here. The C# part of this would go into a partial class of the same name as the component here. It is important that it is a public partial class, otherwise it would just not compile, and the name needs to match up, obviously in the same namespace as well. And the same exact code that I've got here has been put in here. My demo is already running. So if I take you through the demo here, I've extended the navigation which comes out of the box in the Visual Studio template. And I've just lined it up so that I can take you through the demo quickly. The code directive demo, it works fine. It updates the counter for me. And if I go to the code partial class demo, it updates it for me as well. As you can see, there's absolutely no difference in the way it functions. For me, this is all about how I want to lay out my code. And if you're wondering whether in the code directive demo where you had C# and the Razor file coexisting, whether you can actually see the code going ahead in the view source, you just can't. You won't be able to see that. It's all nicely hidden from you. But of course, it's the WebAssembly model, so you would have all the DLLs downloaded locally for you. Let's talk about parameters in components. Components can consume parameters, which is what makes them so versatile, because they can accept dynamic data and then perform logic according to them. The first type of parameters I want to look at is the route parameters. I've got this parameter component here. Let me close the other one. And in my page directive, when I specify the route template, I can have specific values in this format, in this convention. When I specify a string inside parentheses in a route template, that's treated as a route parameter. You can have multiple route parameters. You can even have parameter well within the URL. There is no hard and fast rule that it should be right at the end of the URL. And this is us providing a route template or passing a value. But how does the component consume it? It is consumed by using a public property of the same name as the parameter. So I've got value and I've got other value as two parameters that I've supplied to the route template. I specify public properties of the same name. It's a case insensitive match, as you can see, but I've adorned both of them with the parameter attribute. This kind of matches up with a little bit of convention, and it tells Blazor that this properties needs to be treated as a route template, especially because we have page directives with route template specified for this particular component. And if you are to look at my demo here, in my navigation, I've hard-coded something. I've hard-coded the URL to be parameter / this is a route parameter. Going into the file, I can see that the value property has been picked, the value parameter has been picked up, and it is displaying properly. If I change this to, say, value / value 1 / value 2, say, it's from my browser history, it is mapped against the parameter / value / other value route, which I have specified here. It's mapping up. If I change the value to say hello, it matches it against this particular route, and the other value is completely ignored. At this point of time, I don't think we can have optional parameters in routes. So the workaround for that is to have a route template with no parameters and then specify any parameters that you want. So that's about route parameters. The next type of parameters that components can consume are component parameters. And for that, I've got a little shared component here called display text. I again have a public property here called text, which I'm trying to display using @syntax. And I've adorned this public property with the name parameter. In cases like this, where you have a component without a route template specified, if I have a public property with a parameter, that is treated as a component parameter. Now, if I want to call this component from another component, I would be using the name of the component as a display text. This is what I explained in my introduction slides. I'm using this as the HTML syntax, and the HTML tag is display text going by the Razor component name. And as you can see, something called text is available to me. this text is in fact the parameter that I specified here, which gets available to me as an attribute, and I can pass some values to it. And that is exactly what you see here. There's a third type of parameters, which I'm just going to touch and go. I will leave you resources at the end for your own reading, which is cascading parameters. As the name suggests, something cascades all the way. So these are parameters or values which can be used when you have to conquer a multiple go through too many layers of nested components. Say you have something in your layout component which you want to pass through all the layers, something like a theme value which you want for your application. So in such cases, you can use cascading parameters to achieve this scenario. What you would do is pass a cascading value, and the components would consume that as cascading parameters. There's a little code demo in my solution for this. I will let you read up and have a look at it. Moving on, life cycle of a component. As developers, for myself, I would really love to control the behavior and override the output, if I can, of anything. And of course, for that, with components, we have lifecycle methods. There are 3 or 4 different lifecycle methods which I can talk you through. The first one is set parameters async. So this is the first lifecycle component, a lifecycle event which runs for the component. And the main job of it is to set the parameters for the component. Let's have a look at the signature for this event, which I have got here. It's an async method which returns a task. Of course, it's an override. And it accepts a parameter view object as a parameter to the method. The parameter view object is a collection of parameters and values which the component has received. So my shared component, this is a shared component, and I've got 3 parameters specified as component parameters: first name, last name, and job title. When I call this component from my page here, component lifecycle, I am only passing the first name and last name values. So when the control gets to this method, the parameter view object would only have the first name and last name parameters and their values. I haven't supplied anything for the job title parameter, so that we skipped. So when this method runs, what it does is it tries to match up the parameters against the values it has. And when it finds a match, the value is assigned. If there is no incoming value for a component parameter, that parameter is skipped from any assignment of values. Going to this page and looking at the browser console, as you can see, I am trying to write something into the browser console, and what I'm doing here is looping through this parameter view object and trying to write out what was bound and what is the value. As you can see, when it enters here, the first name is bound and then the last name is bound. The value of the job title parameter is completely skipped. The second method, which runs soon after set parameters async, is the onInitialized method, which again has an async version. It runs soon after set parameters async, and if you have any data initialization, like calling out to a database or a third-party service to initialize your data, this is where you write the code for that and handle the logic. In Blazor WebAssembly, it runs only one time. The method runs only once. And in Blazor server apps, because of the way the server app is, where it pre-renders and then connects to the server using a SignalR connection, this method is rendered twice. Another important point about this method is that if a component is refreshed, say a parent component refreshes a child component, this method is completely skipped upon refreshes. This method gets called only when the component is requested for the first time. The third one is onParameters set. Whenever the parameters change for a component, this method kicks in. It usually kicks in after onInitialized, but thereafter it kicks in every time when the parameters change. Same like before, if you have a component refresh, if a parent component refreshes a child component, the onInitialize method is skipped in that scenario. And in such instances, the onParameters set async method kicks in after the set parameters async method. The last method, which I want to discuss today about the lifecycle, is onAfterRender, which again has a async version. This is the last lifecycle method to run, but that doesn't make it any less important because this method runs only when the component has completely rendered. You might have instances where you want to call JavaScript from your code. You might want to refer to child components and the elements from a parent component, say, for example. So all those child element references, all the DOM is ready for you to query only at this point. So going back to my sample repo, let me first take you through the method signatures for the onInitialized and parameter set async. The onInitialized is pretty much simple. It returns a void. You can do what you need to do here. The onParameter set async returns a task. And if I look at the browser, you can see it running one after the other. The onAfterRender async method returns a task and accepts a first render Boolean as a parameter. So there might be instances where you want to perform logic only for the, say, first render of a component. So in such instances, you can do this check to see whether it's the first render of a component and then perform logic based on that. So that's about lifecycle methods. Data binding. Of course, Blazor is a single page application framework and it supports data binding. The first type of data binding is one-way data binding. So let's talk about that briefly. One-way data binding is unidirectional flow of updates. An example would be to read or display something using @ syntax. It's classic Razor syntax. So if you have a property or a field, @ property name or @ field name can display the value for you. That is a good example of one-way data binding. Sometimes you might have scenarios where I'm trying to display something, but that value is updated upon an interaction from the user side. That still is one-way data binding because it's the application that does the update for me. I cannot do anything myself as a user to update that value. So as an example here, I've got this page. I've got a one-way data binding example. I'm trying to display a field or a property, which I've specified in my code. It's a field. I'm trying to display the value here. I've got a button, and upon click, it does some method. And if you look at the method, I'm trying to increment the value of the current count field. I'll talk about event handling in the next slide, so I'm just leaving it to some method for now. And if I run this demo, upon click me, it updates the value behind the scenes, and I can only display that value. I cannot update it myself. That is the most important aspect of one-way data binding. The second type of data binding is the two-way data binding, which is the lifeline of forms in Blazor. If you are familiar with a JavaScript library like AngularJS or React, more frameworks, you would be very familiar with this concept of two-way data binding, because data binding, you can see it happening real time if you want, and all the magic in two-way data binding in Blazor happens with the @bind attribute. This attribute is specified on HTML elements, say input type text or input type checkbox, and the value of the bind attribute binds to a property name or a field name or even a Razor expression. The bind attribute is quite smart enough to understand which attribute of the native HTML element should it bind to. So for example, in my demo, I have this demo here where I'm binding a first name field in my code to this input type text. So this bind attribute is clever enough to understand that it should bind the first name to the value attribute of the input type text. By default, two-way data binding happens once the user focuses out of the field. So when I step out of the field, the data should bind. So in case of an input type text, it happens on onChange. But I can always override it, and I can set the data binding to happen upon another event. In that instance, to make that happen, I would use a syntax like this: bind :event equals on input. So this tells Blazor that, hey, Blazor, bind this text box value to the first name input field here, but don't bind it on onChange. I want you to bind the data on the onInput event. So if I go and have a look at the demo here, if I type in my name here, nothing happens. There's one thing I forgot to mention. I'm also trying to display the value here so that you can get to see when it actually binds. So let's start all over again. I have pressed tab, focused out. That is when the data gets bound for me. But in the second box where I have changed the bind event to onInput, upon every input from my keyboard, the data is getting bound, and I can see that value changing as well for me. So that's two-way data binding. Let's talk about event handling in Blazor. You've already seen examples of this, but in my demo today, but to just reiterate everything, events can be specified as attributes of HTML element of the format onEvent, where event is the event name. Say, for example, I can specify an @onClick as a event for a button, and the value of that would be treated as an event handler. So when I execute a click action on the button, the handle on click event would run. Event handlers can return async and a task. You can even though the event handlers do not expect any arguments, you can pass it an optional event tags like a mouse event tags or a keyboard event tags if you wish to understand more about what caused the event, or say which key was pressed. Let's have a look at the sample code for this again. One-way data binding. I've got this button here and I'm specifying an event here. And as you can see, it's of the format onClick, onEvent. And I'm specifying a value here called increment count, and this would be treated as an event handler. The event handler is in my C# code here. It updates some value for me, and it is the reason why when I click, the value increments for me. So that's event handling for you. I can also show you something about mouse event tags. So if I click this button, it should write into the console which mouse button was clicked. So for example, if I click this, as you can see, it's updating as 0. The reason being I'm clicking a left button and the value for the left button is 0. And the code for that is here. For the mouse event tags, there's a button which onClick. And in the event handler, I've got my mouse event tags, which updates some value and writes which button it is into the control. I can also pass in a keyboard event tags, which outputs the key which I have pressed. If you want to have a look at that, it's labeled incorrectly, by the way. I'm sorry about that. As you can see, it is updating something in the browser console for me. So that's event handling with an optional event tags. The last thing I want to discuss is accessing the JavaScript runtime. I will very quickly run through this. You can access JavaScript runtime from Blazor apps. So you can call .NET from JavaScript, or you can actually call JavaScript from your .NET code. And for that, you are given a nice injectable dependency called IJS runtime from Microsoft. So this is basically an instance of the JavaScript runtime to which you can dispatch your call. Once you have injected this into your code, I can make use of it in my code. Because it's a JavaScript code, going a few slides back, it needs to be handled in the onRenderAfterAsync method, which is exactly what I'm doing here. I've got the JavaScript runtime, and I've got the invoke void async method here, which accepts an identifier, which is a function identifier, and I'm passing in a series of arguments which are serializable. The function identifier is specified in a scripts.js file, and as you can see, it is specified on an alert scope, and the alerts is specified on the window global scope. So that's one of the requirements of this method, the function identifier must be relative to the global scope, which is the window. Hence, I've got it as alerts and alerts.show alert. It doesn't return a value. And all what I'm doing in my script.js is alerting something that I'm passing to the function. The script.js needs to be referred in the index.html file, which is the root of your Blazor application, because it's from here all the controls go through. And if I have a brief look at the demo here, as you can see, it is getting outputted. Last but least, components can communicate with each other as well. I've got a little demo here where I can see the parent updating the child. I'll let you have a look at the code and read through the samples, but I can also update from the child to the parent as well. So that's my resources. I believe the links to which has been shared. Thank you.
Excellent presentation, Purnama. That was amazing. Everything was very clear, and all of the resources noted. So really, really, really great job. We have one question that I want to get. So let's pull it up. So it's by Cosmo, and it says, can Blazor handle dynamic routes from CMS?
I believe some kind of integration should be possible. This is something that I'm quite interested in myself as well, something that I'm going to look forward to as well. I believe you can do something about it. I haven't tried it myself, but I would be equally interested. So if I achieve something with it, definitely I'll let you know. Okay. I haven't attempted it myself, but yes, I am hoping that something should be possible. You can do something clever.
Yeah, we could play around with it.
Yeah.
Excellent. Maybe if you do discover a solution, we can tweet about it and promote
Absolutely.
that.
I'm on it.
Amazing. I believe let's see if we could pull this one up. This is by Pipe Tabor. How will Blazor perform with an enterprise app?
I have absolutely no doubts about it because Blazor is production ready. And I think Blazor Server came out last year with 3.1 .NET Core. And even before that, people were really playing around with Blazor, and there's millions of blog posts around it. So I am pretty sure the performance will be on par with any other application that you've got out there. And with .NET Standard coming on, .NET 5 coming on board, everything is going towards a more uniform platform, which means you can pull in code from elsewhere, use it, basically, and you if you have written something for Blazor, you can equally use it elsewhere as well. So I think there's a huge potential for Blazor, especially with applications. That is where I see Blazor being used, and I think it'll perform really well.
Excellent. Well, thank you so much for your time and your feedback. We really appreciate it. Excellent session. This was recorded, so if you are unavailable to catch the whole session, you can rewind and catch it on the stream. Thank you so much, Purnama, for joining us today. We really appreciate it. We're going to go ahead and get started and announce our next presenter. But before, I would love to show that we have a really fun swag thing where you can build your own .NET bot. And we have some people posting their really fun .NET bots that they've printed and are tweeting out. So really fun, exciting ones. So go on over to the swag, virtual swag, and get your info for 3D printing your own .NET bot that you can have in your own home. And with that, I think we're going to go ahead and get started with our next presenter. And amazing. So, hi, Cliff. How's it going?
I'm good, thank you. How are you, Jamie?
I am excellent. We are having a great time here at .NET Conf this morning for me in New York. I know you have a lot to cover. So we're going to be talking about remote computer science and PyTop, .NET, and Teams.
No, that's not me.
Wrong session.
Anyway.
I was like, this is not correct, actually. Here we go. We're actually going to be talking about 3D printed Bionic hand with IoT and Xamarin. So perfect timing. I'll let you take it away.
Excellent. Hi, everyone. And thanks, Jamie and Jeff behind the scenes. My name's Clifford Ages. I'm going to talk to you about how I've gone about building a 3D Bionic hand for a friend's son. There you go, my slides will move on. A bit about me first. My day job is that of an airline pilot for a major UK airline. So my office is the picture you can see there. I'm flying tomorrow on a long-haul flight to the US. When I'm not flying planes, though, I'm a freelance .NET, Xamarin, and IoT developer. So I love playing with electronics. I love building things and tinkering with Xamarin and mobile apps and spending time with family and stuff like that. I'll come back to why I mentioned the fact that I'm an airline pilot a little bit later in the talk. But let's meet Caden. Now, Caden's a happy-go-lucky teenager. As you can see there in images, he's very active in the Scouts community in the UK and goes to jamborees around the world as well every year. But those of you more observant can probably see in the picture there that Caden's missing his most of his left arm. He's missing his left forearm, left hand, and on his right hand he's missing all of his middle fingers. So he's just got his pinky and his thumb. Now, you know, Caden is provided by the NHS, the National Health Service here in the UK. So our medical teams and hospitals here in the UK is provided with a prosthetic arm. He's been part of a team that's been studying this, and he was provided one pretty much from birth, from about 6 months old. And he's grown up with wearing a prosthetic arm. But a lot of children don't get that privilege, don't get that chance, because these are expensive devices. Even these dumb ones that you can see here, which are literally just a claw which opens and closes. As you can see here, if I was to pull on this is literally fishing line. It opens and closes the grip. Now, as you can see there, Caden's got this, and his party trick is to do that when he's on London Underground. He's off to the London 2012 Olympics there. But you can see the fishing line just coming off the arm. It goes across the back of his shoulders to a pad on his other shoulder, and as he moves that shoulder backwards and forwards, it pulls on the fishing line, and it pulls open the claw. And then there's elastic bands that pull it closed when he relaxes his shoulder. Every year, Caden has to go back to the hospital. Every year, they take a cast of his arm, of the stump that he has, and they make that into a mold, which they then use to create his next new arm. And in typical kind of mum's kind of way of saying things, don't worry, you'll grow into it. They make it slightly too big, and after a couple of months, he grows into it and it fits. And just when it starts becoming tight, it goes back to the hospital and repeats the process. This process costs the NHS in the region of £4,500 to £6,000 every time. So they're not cheap. It takes a couple of days of Caden's time and his family going back and forth to the hospital. So this is a picture of a prosthetic arm that was issued after the First World War. And you can see here, the design hasn't changed much. It's pretty much the same. It was a leather strap back then rather than a fishing line. And it just moved the forearm backwards and forwards. But this one is 100 years old. This is a picture in the Imperial War Museum in London. I took a few months ago when I was there visiting. So you can see here, the design hasn't moved on. Now we can do better than this. But let's see how good Caden is with his prosthetic arm. Here he's making me a cup of tea. Us Brits, we love a cup of tea. So this is me recording him making a cup of tea. So you can see he's quite dexterous. You can see the strap goes across his back and his shoulders when he moves in a moment. You can see the strap there. And he's quite dexterous. He can pick up a tea bag. He can pull it apart with his finger and pinky. And you can see there he can make me a cup of tea. Now, Caden's been, as I say, wearing one of these for a number of years. But we wanted to do better. So we searched the internet. Now, we start off with Google, Bing, etc. And we search around. And the first thing we come across on the NHS was links to the Limbless Association. Now, I've been giving this talk and been working on this project for a couple of years now. And the Limbless Association is still under development. So I think that developer needs to be given the hurry up or get a new developer in, I think. But what we come across was the Team Unlimited. Now, this was because there's a story on the national news in the UK about a dad that 3D printed his daughter an arm. And that's where this whole idea come from. So we found Team Unlimited. We printed one of their arms, not the Isabella. It was a slightly older version. So I started this about 2 years ago now. And that version we gave to Caden. He tried it on and he was okay, but he felt we didn't give him any more than his hook that he had currently, because the fingers clasped, but it didn't do anything else. It just basically, he still had to move his shoulder. It still did the same job. So he wasn't very keen on it. So, you know, as a pilot, we're giving feedback and we take that feedback open and honest, and we don't sort of take it as negative. It's like, okay, right, that's where I need to improve on. So we went back to the drawing board, back to the internet, and I stumbled across the Open Hand project. This was a university project by Joel Gibbard, and he built a electromechanical hand, again 3D printed. It's quite bulky, it's quite beefy, the control wasn't very good. The 3D printing was a bit, as you can see, a bit edgy and bulky. But you can see there, he's starting to look into prosthetics, and the fact that biomechanical prosthetics cost upwards of $100,000. Joel then went on with others and created Open Bionics, which is a wonderful team based out of Bristol, where they produce these arms and they sell them around the world. Initially, Open Bionics was a open platform, and they produced or showed their designs on GitHub, and we all know and love GitHub. But because they were trying to get these sold into the likes of National Health Service in the UK and sold into markets in the US and Germany and France and places, for obvious reasons, they had to close the design because they couldn't have designs coming in and changing for the fact that they needed to get it quality marked and quality assured, etc. So they closed the design. But there's enough of a design there, and they put enough online for us to move on. So we go back to the slides. I downloaded the Brunel parts off of GitHub, fired up the 3D printer, and printed off all the parts there. You can see all the parts in white and red on my cut map there are all 3D printed. You can see the bags of screws and springs and dowels and things. They're purchased off the internet. And you can see the 4 Actuonics motors in the top left corner of the map there. So now we've got all the parts, we need to work out how to connect it to Caden. So we needed to take his mold that he gets from the NHS. It's one of these, and we need to work out how to make the arm fit to Caden, how he's going to connect to Caden. So you can see there it was printed along, and you can see in the timer here, there's 5 hours and 45 minutes left of printing. So I went off to bed, as I normally do when I'm sending 3D prints, and come down in the morning to find the spaghetti's mess. The left-hand image, you can see the socket had popped off the print bed, and it fell to adhere correctly, and it popped off, and it printed the left of the mess. But the middle image, there was enough printed for us to try. So we went around and popped over to Caden and see his family, had a cup of tea, and we tried it on. And this one in the nursery rhyme style, this one didn't fit, it was too small. So we printed another one, as you can see in the right-hand picture, that was too big. So we printed a third one. The third one was just right, and it fitted like a glove. To the point where Caden actually said it fitted better than the NHS one. Now, this 3D print, it does take a few hours. It's about 8-9 hour prints to get one to print, but it costs 80 pence in PLA plastic. 80 pence plastic was what, $1 in plastic. So that's pretty darn cheap. When Caden grows out of it, as he does every kind of 6 to 9 months, rather than having to spend days going out of the hospital and waiting weeks for a new one to be made, we just click print. Following day, he comes around after school and picks up the new one, screws it into the hand, and he's off again. And it costs us 80 pence. So, you know, that is kind of where we're going with 3D printing technology these days. So we look at the prices of all these 3D printed parts. Now you can see the top there is the molds that we use to put the thing grips on. If I go on to the next slide, you can see the black elements there are the urethane molds. And the reason is because the plastic that we print with is quite hard. It's like Lego plastic, and it's quite slippy, so you can't grip things. So we mold urethane rubber onto the end, which is the same sort of thing, like neoprene and stuff that you make swimsuits out of. So we mold that on, and we use those molds. I've used those molds to make about 15, 16 hands now, and on the same mold. So that is a one-off cost of £10, $12. The actual interesting parts are the bits at the bottom image that we need to make. You can see at the bottom there, without the molds, they cost £5 sterling or $7 to make all the parts to make the hand. You add on the 80 pence or another $1 for the socket, and about $1.50, £1 to make the central part of the arm, which is different for every person. So obviously where their arm stops is different for every child and adult. So you're talking less than $10. We've got all of the printed parts, all of the 3D printed parts. So already we're beating what is provided by the NHS many times over. So you can see here, this is the handy moving. He's okay with it, and you can see there it moving around. Now it works by, you can see the strings just pulling on the fingers, and as the string is literally a fishing line, Brady fishing line that pulls. So we're back to the fishing theme. It pulls via the motors, and it pulls the fingers in, and when it releases, the springs pull them back out again. How do we control it though? Well, Bionic, when they originally released this design online, they had the chestnut board. They had at the time when we started this project a store where you could buy the components that you needed. And the chestnut board always seemed to be out of stock. It was quite expensive. It was £250 plus VAT, which is our sales tax here in the UK, and postage and packaging. So it was quite expensive board. But at the end of the day, it was just an Arduino SAMD microprocessor, and nothing much else. So it was expensive and difficult to get hold of. So it kind of wasn't ideal. How do they sense the to control the board though? Well, they use these malware sensors. And these malware sensors, as you can see in the image there, they use the little sticky pads. So if you ever have an ECG with your doctor, they're little sticky pads that stick onto you all over your body to measure the electrical signals your body's sending around. So these pads stick onto these boards. The boards stick onto the muscles. And if we look at where they stick, you need to stick them quite centrally on the muscle group to get a very good signal. As you can see the green signal there, the correct placement. If you stick it off place, like slightly higher, slightly too low, you don't get too much of a signal from it. So you need to make sure you put this in the correct place. Now, we could do that, but if you imagine giving this to a child, those boards are 35 to 40 pounds, so $40 to $50. You need 2 of those. The pads, a pack of pads to last you a month is $5 to $7. So they need to be changed every day because obviously they lose their stickiness. The child has got these expensive boards stuck to them. It's not ideal. It can break quite easily. So how does that malware sensor board work? Well, if you all grab your arm and put it up, straight up, and you put your fingers either side, just above your elbow, and if you do the close, which is where you pull your hand towards you, you'll feel the muscle at the back go tight. If you open out the other way, you feel the muscle at the front go tight. If you hold your hand straight up and you create a fist, you'll feel both muscles go tight. So all we do is we have open, close, change grip. And change grip goes to the next grip in the grip sequence. Fairly simple measurement. Now, I realized that we could use that and come on to a different way later of how we measure those signals. That means that in the Bionic codes that they load into the Arduino board that they produce, and they've created 5 grips, which is better than what Caden had. He had just 1 grip, open and close, and he can just pick things up. But now he's got a palm grip, so he can hold a bag, so he can help mum and dad with shopping. He didn't like that grip. He can have a point gesture, so he can point it over there to his friends. He can have an OK gesture, say OK. But he wanted more. He was like, well, this is great, but I want one to hold my Xbox controller, Cliff. Okay, we'll put that on the issues list, and we'll come back to that later. But how does it work internally in the code? Now, if we look at this array here, this is a 3D array that's held inside the code base. So if we want to add a new grip, we have to go into the code. So we have to fire up VS Code. We have to go in and edit the code. We then have to connect the board. So we have to take the hand apart, connect it to the PC and load up the code. But you can see here, it's, for us as software engineers, we can work out what this does. But how about Caden, parents, the doctors and nurses, the technicians at the hospital? We don't really want them editing code because, they can make a mistake and cause damage to the mechanics of the hands. But also, it's quite complex for them. They're not trained software engineers like we are. So again, I was taking that up as a mental issue to come back to and try and fix later. So drawbacks we talked about, we've got a single source supply of a board, it's often out of stock. The muscles, also those muscle sensors, as the muscle grows in strength, because Caden's been using it, we need to get a jeweler screwdriver and change the little potentiometers on the board to change the gain values that are coming out, which again isn't ideal. The grip sequence, if he misses the grip sequence, he goes around that array, he's then got to remember, okay, I've missed the point one, so now it'll go 4 grips again to get to the next one, and then it'll be the point one, which is the one actually won. Wasn't ideal. Maybe he wants a different set of grips when he's at school from when he's at home. He doesn't want the Xbox controller grip when he's at school. So we're talking that as the drawbacks we want to try and fix and push back into the Bionic project. So how do we fix the first one, the controller? I use these Adafruit featherboards in a lot of projects that I do with IoT for clients. The Adafruit system's fantastic, based out in New York. And this featherboard system they have, they're all the same form factor and they just have different areas. You can see at the bottom right there, the red board, that is a Bluetooth sensor. You can get one with Wi-Fi. You can get one with LoRaWAN, which is a radio frequency. You can get one with GPS. They come at all different sizes, but the actual pin out and form factor is identical. So I got a few of these. I got them from Amazon just to prove the point you can get them anywhere. They were delivered next day for less than £20, less than $20. Next day, the postman was knocking on my door and delivering one of these. So they're fantastic. Got a built-in battery charger, LiPo battery charger. So lots of things to chalk up. It's like, these are brilliant. Let's go with one of these. So we built one of those. We added on the Adafruit also make a motor controller board. You can see that the other board that's there on the image, and we use that to control the motors. Initial problem was the fact that the motor, the cable, the flat ribbon cable that comes from the motor is a flat ribbon, and we got through holes, so we need to find a special connector. We managed to find one of those and soldered that into the circuit, so that's had it working. Now we need to load the software. Now, anyone that's used Arduino knows and loves the Arduino IDE. It's effectively Notepad-esque IDE. It's not very good as an IDE. It's not as full-featured as VS Code and Visual Studio that we as software developers know and love. It's more of a hobbyist IDE. VS Code is really good for programming Arduino, but it uses the Arduino IDE under the hood, and you can't debug still. With Visual Studio, we know and love F5 and F9 for debugging and making breakpoints. And if you use this Visual Micro add-in for Visual Studio in the store, you can add in and control and burn your code down to your boards. Also, you get debugging back, so it's awesome. I can't highly recommend this enough as an add-in for Visual Studio if you're going to do any IoT development. So now let's get onto the muscle sensors. I was flying along. I remember it quite vividly. I was off to Japan. I was somewhere over Russia, and I take magazines with me to read in the cruise when the autopilot's engaged. You know, we often have something to read, a Kindle or a magazine, and you know, we'll read a bit of an article and look up and make sure we're managing the aircraft correctly. And we also make sure that someone's flying the plane and the other person can relax for 10 to 15 minutes. And there's an article about Arduino debugging, and we noticed this sensor in the bottom here, which is a, I've not drawn that very well, but a piezoelectric sensor, which basically is used in guitars, it's used in explosive demolition, and basically it measures an input. So if you hit it or bang it, it gives you a small voltage out, which you can measure as a signal into your Arduino board. I was intrigued, so I got to Japan, ordered a bunch of these, and for less than £1, I had 10 of them on my door the following day, waiting for me for when I got home. But we tried it, and Caden wasn't happy because he couldn't stop the hand mid-flow like he could before with the malware sensors. Okay, we'll go and look for something else. So then we come across these force-sensitive resistors. Now these, as you apply pressure, they give you a different resistance. So you send a voltage for it, and you get a different voltage out. You can measure that. Excellent. Now we've got force-sensitive. These are £6 for a pack of 2. So rather than the £35 each for the malware sensor, we're now down to £6 for a pack of 2. We could stick those quite happily inside the inside that 3D printed socket that Caden slides his arm into, and now we can measure, because the muscle goes tense, it pushes against that hard Lego type plastic, and we can measure the signal coming out. Awesome. So now we solved that problem. So drawbacks then: single source supply from the board, often out of stock. Adafruit and the derivatives of lots of other companies are copying their design now. So we're quite safe in the fact that it's not going to go anywhere. We get from Amazon. The muscle sensors, well, we've replaced those with these force sensitive resistors. Again, I bought them from Amazon just to prove a point, and there's many manufacturers of these, all different shapes and sizes. So that's good. So now we're down to the grip sequences. Miss it, you go around, you want to make your own grip. Okay, well, what can we do about that? Well, I said earlier that I'm a mobile developer and I love Xamarin. So I thought to myself, well, I've got this board, it's got Bluetooth on board. I can write a Xamarin app, and the Xamarin app can access the Bluetooth stack. So I can write this app that accesses and sends data to and from the Arduino board. It's in the back of the hands, and I can write an app about it. So I was like, this is excellent. So this is what we went with. So just a little bit about Xamarin Forms, just in case you haven't seen any of the other fantastic talks by Maddie Legier and David Ortnow and others on .NET Conf. If not, go back and watch them. But very quickly, you got two versions of Xamarin. You got the traditional one where you build your own UI layer, and then it's all C# backends. Or the one that I'm now leaning towards and favour is Xamarin Forms, because it's moved on leaps and bounds. It's no longer really the forms bit should disappear. It's no longer just for that business layout form. and some amazing apps have been developed using Xamarin Forms. And the shared UI, so I write the UI layer in XAML or in code, and it will share and look as it needs to look on each of the different platforms. So that's what I did. So if we bring across the Handy app, so this is my my phone sitting in front of me. Here's Handy, so we can see Handy here. So if we open the app, you can see it takes a few seconds to boot up, and we open up. It says connect first, so if we connect that and we plug the battery in and start scanning, we can see Handy appears in the Bluetooth. It's now connected. So now we've got Handy connected. And if I go across to, run quick enough and go across to the UART control, you can see the fact that the two are communicating in the background over UART. And this is used for advanced features on Caden and his family's version of this of the app. They don't have this functionality. It's just for me as a debugging. But if we go back to the grip selector, I can now push the big button and close the hands. I can open the hands. I can move to a different grip in the grip sequence, and I can add them to my favorites. So I can put them onto my favorites and add them into the list. I can go to the grip order. Maybe Caden wants his grips in a slightly different order. So he can change the grip order, save it down to hand. So now when he goes around the grip sequence, it's a completely different grip. It's going to remove the battery for the moment. That whining, if you can hear it over the speaker, is because I've got two dogs, and when I'm testing, if I leave it running for too long, they start getting upset at the high-pitched voice sound. So I've tuned it down so it's out their audible range in ours, and they're not so upset and they don't go barking at me. But the other thing is we can do a grip builder, so we can make our own grips and save them to the hands, which is fantastic. He can now make his Xbox grip and add it to his sequence. The other things we can do is we can go into the settings. We can change the settings of the hand, if it's a left or right hand. We can change the hold and peak threshold, which is settings in the hand for that timer that runs round. And also we can change the way the muscles and that work. So this is the sort of thing that the technicians and the doctors and nurses would need to change at the hospital. But also we can do a muscle sensor check. So every week or two, Caden runs into this, he starts it and he runs through what we tell him to do, which is open, close his hands and try and get these bars, these two bars here, that one there and that one there. Try to get them to the top and hold them for a second or two and release them again. We then send that data for processing. It goes up to an Azure function, it gets put in blob storage, and we're collecting that data. We've been doing this for a number of months now, and at some point in the future, we're going to get some machine learning to reason over that data, and then change the values that are in those dwell times that were in the settings to save him having to go in and change it himself. So we come back to the slide deck. Caden's now got his Xbox grip. He's over the moon. He just needs the new latest Xbox. And not the old one. He's waiting to get one here in the UK. Santa's not too far away, but we've got an Xbox grip where that trigger finger just twitches. So as he twitches his muscle, he can twitch that in and out. So he doesn't need to completely open and close his arm, but it just moves that trigger finger, and that's fantastic. He's over the moon. He can now play his Xbox without needing the adaptive controller that Microsoft produced. So now let's look at the cost then. So all the parts, the 3D printed parts, as we said earlier, come to £10 to £15, everything, that's the molds, everything. But all the other parts we need to purchase and buy literally arrive, and they cost just over £500. So what, $680. So the National Health Service is spending £4,500 to £6,000 for a fiberglass arm without the hook, I might add, because that's a few thousand more. The hook is interchangeable and he gets that moved to the next arm as he moves along and grows. So just the fiberglass part that's made. I'm managing to make this for just over £500. Obviously, there's none of my time in there and the software and the bits and bobs behind. This is just pure mechanical parts and the software. But I've written the software. It's on GitHub. It's open source for anyone to go and download and play with. That works on the Adafruit board, not on the Chestnut board for Bionic. And I'm planning to open source the app as well as we get it to a point where it's usable for all. But the app and everything else, it's there and it's super cheap. So what's next then? Well, I want to finish off building a mobile app out. The version that's on my GitHub at the moment, that's open source, isn't the version that's on Caden and his parents' phones, purely because there's some personal information in there that we don't want to share on GitHub, and we want to be very careful about what we're sharing here on the data we're collecting and how we're collecting it. So once we've got it to a point where we're happy, we'll desensitize the app and then push it up to GitHub again in the open source version. We want to get machine learning to reason over that data and send the data back to the app, so that when he arrives home from school and he turns his phone on, the app gets the new push data, and he connects his arm and it will connect up. We'd like to go full .NET, which I'll come on to in a sec. But also we're moving on to prosthetic legs. We've realized that actually this 3D printing stuff is quite cheap, and we want to fix the problems with legs as well. And that's because my uncle recently had to have a leg amputated for medical reasons, and we'd like to replace the leg that he has, which is pretty much a stump. Yeah, we'd like to fix that as well for him. So moving on to full .NET, not sure if you've seen it, but you got the Meadow Micro F7 board, which is the same form factor of the Feather board, but it runs full .NET and a mono runtime. These are slightly more expensive, about twice the price, but it's .NET, which means we can do a lot more machine learning on the board rather than in the cloud. So that's bringing IoT direct to the edge. So that is absolutely fantastic. And I do have one here, and we're trying to get the software to work on there and control the motors and get it working. So why did I mention being a pilot? I just said at the very beginning, the idea behind this project, quite soon after we was doing this and I started giving talks, people were very interested, and people around the world were very interested as well. So what I want to do is put a 3D printer. I was hoping to do it this summer, but obviously COVID has stopped that. But put a 3D printer and some parts into a box and a couple of spools of filament, take it somewhere around the world where they don't have the wonderful NHS or health services that Europe and America tends to have. Take it somewhere, go to a hospital, drop it off, show them how to use the kit, and then pop back a month later and see how they're getting on, and be on the phone or team or Skype call later on to help them out, so that they can give back to the local community, because they may not have $4,000 to $6,000 to produce these arms for children locally, whereas we can produce it, much better device for much less money. If you want to jump in, you can find me on GitHub. It's GitHub/CliffAges, and you'll find all the handy parts in there. You can jump in and help out. That's it. Thanks for joining. I just want to say a massive thank you to Caden. He's been fantastic with the feedback. He loves his arm. He loves playing his Xbox. To Caden's family as well, that test out the app as well. They get a push from App Center every time I push it to GitHub. They get a new app update from App Center. They love it. They give me feedback on WhatsApp or via App Center. And also massive thanks to all the behind the scenes people here at .NET Conf that are helping out, that I don't think get enough praise. So thank you, everyone. Thanks a lot.
Amazing. Holy cow. That was phenomenal. Thank you so much, Cliff. And thank you, Caden, and your family. It looks like you're doing well, and we're so happy for you. We're a bit right at time, and we didn't collect any questions for this session.
Okay.
But yeah, it means you answered everyone's questions without fail.
Well, me, they can reach out to me on Twitter, so they can find me there.
Perfect. So everybody, please go and do that. Ask all of your amazing IoT questions to Cliff. Thank you, Cliff, for joining us. We really appreciate you, and we'll look for you soon.
Bye now.
Take care. Excellent. Okay, so we are still on time, which is a great thing. I'm doing okay as a host over here. So let's go ahead and move on to our next session, which is remote computer science with PyTop.NET and Teams. And I'm joined here today with a couple folks for this presentation. Hi, Mark. Hi, John.
Hello.
Oh, Mark, you're muted.
There we go. Hi, everyone.
Great. Well, I know you guys have a lot to talk about, so we'll get right to it. Go ahead and take it away.
Okay, I'll just wait for the slides to come up. There we go. Well, hi, everyone, and welcome to our demo of a remote yet hands-on robotics class. So I want to set the scene a little. You probably all know that the pandemic has forced many schools to limit access to or even shut down their computer labs. Labs are a real problem for schools. It's quite hard to sanitize equipment after use, and you often can't send expensive equipment home with students if they're working remotely. But labs are also really great for students. In a labs, students practice learning by making. It's hands-on, it's engaging, and it does improve outcomes. They also provide a great collaborative environment for students where they can practice all those important workplace skills like teamwork and project management. So the question that we're exploring with this demonstration is how can we retain the benefits of lab-based work when some or all of the participants are working remotely? And it's an important question because, you know, schools may be working this way on and off for some time, but there are other benefits. You know, in many regions, educational institutions would like to maintain the benefits of remote working, regardless of COVID-19. It allows remote experts to join classes. It enables students that could be in isolation for any reason to continue to work. And it supports new paradigms. For example, you know, you can get a replacement teacher from just about anywhere. Today, we're demonstrating a remote-friendly collaborative class. I'll be taking the role of lead teacher. And I'm joined by John, who's our technical expert. So John, how have we set things up today?
So first, in our lab, we have the Raspberry Pi-based PyTop 4 robot kit. The robot has two servos and two motors. And we've, for the demo, we're just going to use the servos. We've arranged the servos to form a gimbal. And sitting on top of the gimbal, you can see there's a wide-angle USB camera. We can use that to look around the lab. We also have a couple of LEDs mounted on the front of it so that we can, you know, program it to send feedback that we can see. We've got two students in the lab, and they're in separate locations, Mike and Diego, and they're working in the UK. And Mark, you're a teacher. For the folks who are watching, Mark is in Europe, and everyone is going to be communicating together using Teams. So there's, advance the slide there if we can. So most of the people watching, like most of the people watching, Mike and Diego are familiar with C#. They're C# students. They've done that a bunch. So they're eager to get their hands dirty with the PyTop robot kit. There's one slight problem, of course. The rover is in Diego's lab. Mike is in a separate location. Mark's in a separate location. So to get around this, we've got the robot. It's joined to our Teams chat, and we can send code to it using C# right from within Teams. And that allows us to communicate back and forth and share a working environment. So in our demonstration today, the robot is going to be searching in its surroundings for Pokemon energy cards. And it will be able to recognize them using an AI model that we've trained using Lobe AI.
Okay, so, well, that's super, John. So we are going to show a little more of Lobe AI later. And for those interested, we're also organizing a separate Twitch with the Lobe.ai team. And we'll go in that Twitch much more deeply into its capabilities. Okay, so today, Mike and Diego, who are our two superstar students, are going to be learning some robotics, training a classification model, and all while interacting in real time with a remote PyTop robot. This class is for reasonably advanced students. However, I hope by the end you'll be able to see that, you know, given some time, it would be relatively easy to use the same approach to learn some more basic coding principles. I want to stress that we're all remote. You know, John is just rising in Seattle. I'm in Andorra in Europe, and Diego and Mike are in lockdown in different parts of the UK. Diego has the rover in his lab, and we're going to be interacting with it via Teams. So, John, let's chat about the setup a little bit. Students can program robot behavior, but what does that actually mean? Can you kind of drill into that for me a bit?
Yep. Yeah, so because everyone is sharing the hardware remotely, we needed a programming model that would let the students collaborate in real time. The program is running on the rover. It's a custom program that we built, and it has an embedded .NET Interactive C# kernel running on it. So one of the objects that's exposed in the rover's programming model, we call it rover brain. You can see a little sample here. And it runs in a loop, and the loop has three phases, and it's perceive, plan, and then act. So perceive is used to take an input. We can take pictures with the camera. Plan is used to evaluate what we're seeing. So we can call out to the Lobe AI model and say, you know, did we find an energy card? And then the act is used if we have a plan, if we have some actionable piece of information, we can then act on what we saw. Now, the important part of this is that each of the perceive, plan, and act stages are delegates that can be overwritten by the students independently of one another. So the loop keeps running, but the different delegates can be replaced. And what this allows is different aspects of the overall task, we can iterate on them, and different people can contribute their own tweaks and changes to that model as we go. But Mark, the question that people are going to ask now is, why are we doing this through Teams and not through Visual Studio Code, for example?
Right. I mean, that's a great question. So the answer is that Teams is already deployed in over 50,000 schools, and it's relatively easy to use. Teams, sure, it doesn't offer an advanced coding experience, but it also doesn't require an administrator to set up tunnels and open ports and firewalls in order for everyone to access the robot, which is really a huge benefit for schools. Today, we're going to be showing an early proof of concept. Over the coming months, we plan on advancing this experience, and hopefully in the future, we're going to be running some trials with real schools. We're also providing access for all of you guys watching to the code that was used to create this work. And note that you could actually do most of what you're seeing here using VS Code and notebooks, which is simpler to set up than using Teams, but of course doesn't have the benefits that we've just described of using Teams. So John, how is it that we are connecting the rover to Teams? Tell me a bit about that.
So yeah, like we mentioned, we have an embedded .NET Interactive kernel running on the rover. Now, a lot of folks have seen the .NET Interactive notebook experience running in Jupyter and VS Code. And the thing to understand is that .NET Interactive is really, it's a general purpose server for interactive program. You can embed it, you can stand it up using a notebook, but you can also use other kinds of front ends for it. And so in this case, we have this Teams rover bot that is joined into the chat, and that's our front end. We're using Teams as the front end for code. So you can send code into Teams. It goes over HTTP to the rover. It gets processed by .NET Interactive, and responses come back to Teams.
Okay, well, I think with that, it's time to go to school. So we're going to show how a class might advance the behavior of our robot. We don't have a lot of time, and we're covering a lot of functionality. There will be, I hope, some time for questions at the end, depending on how things go. And we will provide viewers, as I said, with access to everything, including this script. So if you're interested, you can go and review it again. Clearly, in a real class, we'd be taking things a little more slowly. All right, Diego, how about you share your screen? In fact, you have already, for everyone watching. And Mike, let's say hello to the rover.
I don't think waving works, Diego.
No?
I tried earlier.
All right, so there we go. I think you can see that we can, the rover is responding, and we can test the lights and see that they're flashing. All right. Okay, and Mike, have you finished typing there? Yes, you have. Okay. How would we ask for help, for example? How do we find out what the rover is capable of?
Well, I'm going to do the same thing as I did when I was saying hello, and I'm just going to say help directly to the rover.
Okay, nice. All right. Well, let's quickly show you how we'd use those commands to invoke actions. Can you turn the camera? Let's see what's off to one side, for example.
Yeah, sure. So I'm going to pan 60 degrees.
Excellent. And there we go. Okay, guys, as you can see from the help, we have three main objects that we can interact with. There's rover brain, rover body, and resource scanner, as we said before. We can also send general code to the rover for execution. For example, Mike, could you make the rover move its camera from side to side for me?
Yeah, get a bit of shaking action going on. Got a for loop here, just adjusting the pan from side to side with a short wait in between.
All right. So you can see the camera moving around there. Our rover appears to be surrounded by a load of interesting things. And in particular, there's a number of energy cards scattered around in the field of view. So these energy cards are going to play a pretty important part of our work today. We're going to see if we can get to the rover to scan its environment and find the energy cards. And of course, this is a hugely important topic for autonomous vehicles. They all need to be able to perceive, plan, and act. There are applications of this basic model in self-driving cars, robotics for mining or search and rescue, and even within smart cities. So, okay, let's start with the basics and build up. Diego, do you think you could just capture a picture for us?
Yeah, let's try to do that. We got API to do that. I'm going to use the body is one of the things that we've seen from the docs. I'm going to use the camera and get a frame, and then I'm use the preview to make a slightly smaller version so I can send P across, because I would like to see the feedback of what the screenshot is actually in Teams. There you go.
Right. Okay. So that's a nice shot. But, to be honest, that's probably slightly too wide to be useful for our classification.
Mm-hmm.
Can we focus in a little better?
Yeah, sure. We got some additional API to help us with that. On a frame, I can actually focus. Focus will cause that to grab a smaller section in the center, which is quite useful when we're going to do classification to focus our machine learning on parts of the image instead of being confused by the wide angle of the camera we've got.
Nice. All right. So here we have an image, but as we've discussed, we're using Lobe AI to be able to classify objects that we're looking at. So do you think we could show how that works? How can we grab an image and classify it?
Okay, first thing we need to do is that, again, when Mike did the help, we said it was a resource scanner. I can use the resource scanner to connect to Lobe AI. I can run a model straight on the PyTorch, of course, but in this case, it's more useful if I do it on my machine. That's going to allow us to do some very quick turnaround if I need to teach something new, or if, for example, I've got something that is wrong and I want to improve. But I'm going to show you that. Now, let's try to move somewhere else and see if we can find anything interesting. Then we go to the location, and I use all the stuff we've seen. I wait, and then I'm going to ask the resource scanner to use Lobe AI to classify, and let's see what was the outcome of that.
Oh, we've got a delay.
Yeah, there's a big delay.
Let's try it again.
Or I can just re-eval the sector. Oh, not sure.
Go figure. Live demos, hey?
Yeah.
Works every time. Well, let's not get stuck on that for too long. Maybe we can play around with that and show it in a minute. I just want to recap for the audience. We have a rover with a camera and a gimbal. It can take pictures, and we have a model that we can use to classify them. But what could we do with those building blocks, Mike? What sort of experience could we build with that?
Also, what Diego was just mentioning with the frame focusing method is that rather than taking that wide view that we've got of the everything the camera can see, we can split it up into smaller sectors, and we can scan each of those individual sectors for an energy card.
Okay, let's go ahead with that.
Okay, I will send this to the rover. Diego, would you like to chat us through what's going on here?
Well, so now what I'm going to do is then I'm going to create a bunch of sectors. It's going to be quite useful to have our field of view in a grid that we can go and scan through. So I'm going to do a 5x5 grid, and our field of view is now 120 degrees left to right and 45 vertically. And so now we can go through them, and that's going to be the kind of things that we're going to try to go across and find resources and images.
Okay, so I'm going to set up some additional rover behavior here. I'm going to start off by defining a clear state function for the brain. What this is going to do is it's going to reset the camera position, make sure the LEDs are off, and clear out any existing sector data. This will allow us to do some nice little special functionality to clear the state, and you saw the camera reset there. We can use this later on to force a rescan of the environment, but before we do that, we need to define the stages that John mentioned earlier. But before we do that, I'm also going to add another function here, which is going to help us along our way, which is going to allow us to determine when all the sectors have been scanned. And now that we've got that set up, I can start defining the actual stages of behavior. And I'll start with the act stage here. And all we need to do in this stage is move the camera to the current sector. And the tilt controller knows how to find a sector from its coordinates. So next off, I'm going to define the robot's actual perception. In this perceive stage, all we need to do is capture an image of the sector, And to make sure the camera is stable so we get a good image of that sector, I've added a short delay. And then I've used the focus method that Diego showed us earlier to narrow in on that specific part of the image. I've never been very good at planning, so perhaps Diego, you can take care of the plan stage.
Yeah, let's try to do that. So let me put our plan delegate here. So what we're gonna do with the plan now, and I'm gonna use the function that we want to stop if we went across all the sector, and that's when we return no plan. If we have a sector, I'm gonna flag it on, and then I'm gonna try to find the next one that we haven't seen yet. If we go one, we return a new plan, so that in the loop that we had before, we can act on that decision, and your function will go through it and move to the new sector. If we don't find anything else, then we stop, because that means we went across our field of view.
Okay, nice. I just want to make sure everyone understands that this is very collaborative and remote and real time. Diego and Mike are in different locations, and they're both, interacting with this rover independently on different parts of the programming model. So, and as you can see, the rover is actually scanning around and checking its environments. And once all sectors are mapped, it will stop and wait there. So, we've basically got something working around and mapping its environment. What do we do now, Diego?
Well, I want to show you the fact that we set up that classifiers, our resource scanner, to use a model, and I told you I was running that locally. So what that means is that I have an instance of LobAI running here, and as you can see, I have trained it to recognize some of those Pokemon cards, and then every time I capture a frame, I can use that to classify and see what type of energy has been found. Now, the fact we're not running the model locally, that I'm using this one, is that if there is any change, this model can be updated on the fly without having to continuously upload and transfer things between the devices. It's making everything a little bit faster. And if I were to change, like rejecting or making a correction to this label, my confidence will change. So now I want to use this part to go through and enrich each sector we've got with what kind of an energy card we found so far.
Yeah, that's awesome. Okay, so I'm going to jump in now and just define a couple of extra important functions on our way. I've got a function here that will let us know whether a sector contains an energy card. It's quite a basic function. And I've got another function here which will add a classification label to the sector using our LobAI model.
Okay, that's great. But how do we know if we've actually captured something? How do we know if it's worked?
Oh, okay, let me answer that. So let's start from where we were before. So let me put back. So this is the plan as we have it now, right? And we got some LEDs. I'm thinking of doing this. I'm gonna use the function that we've got. So after we flagged the sector as visited, I want to analyze the sector using LobAI for an energy card. If we found anything useful, I'm gonna use the LED and blink it so that we can get a feedback about the fact that the rover has been seeing things. And otherwise, no lights. Then after that, we keep going with the loop as we had before. And I'm going also to take advantage of the reset state that Mike just defined, because I want to reset state so that we can go off and see the rover using our new plan, scanning, and hopefully finding things around that would be useful.
Indeed. Well, that's really nice. So we can already see that the rover is indeed scanning around its environment, looking around with the camera there. It's clearly doing the mapping and hopefully classifying what it finds. We can see the lights are blinking there. Mike, can you tell us how, now that it's mapped the environment, how could we actually get to the information and show what it's learning about its environment?
Well, Professor Hardwick, we can query the scan sectors directly. Let me just put that in now. This should return us a table that shows us what we found and how many times we found it.
Let's see if it works.
Be nice if it came out with the output.
Yeah.
But that being said, we can, like John mentioned before, .NET Interactive is a backend for all sorts of things. So one thing that I can do at this point, we could even try to display the information using VS Code. Let's see if I can get that table. Oh, nice. That's what we got.
We will not Wonderful. Be stopped by Teams.
That's brilliant. That is brilliant. Okay, so we are mapping the environment. We are capturing statistics. I think it's now time for a challenge. What I want is I want our rover to find 3 distinct energy cards utilizing the least amount of power. So once you find 3 cards, I'd like you to stop scanning to save battery. How would you approach that?
Well, challenge accepted. I'm going to roll out another function here that should help us get there. And this will help us determine if we found enough energy cards. Sorry, give me 1 second, excuse me. So first of all, we're going to filter for the sectors where we found an energy card. And then we're going to use the select function to extract the label from each result, remove duplicates by calling distinct. And then we're going to compare the count to the defined number that we're seeking, which will help us to determine whether the challenge has been completed.
Well, sorry, Prof, but I think that function, I think my copy pasted from Stack Overflow.
I've been rumbled.
Yeah. Damn. Gold star for you, Diego.
Okay, so what we want to do now is that despite of, I mean, that's if it's from Stack Overflow, so it's clearly is a function that's going to work. Therefore, what I can do is that I'm going to use the previous logic that we had, but because now we got the function, I could try to short circuit our termination condition. So if we've seen all the sector, or if we match the goal of the 3 resources, 3 energy cards in this case, we can stop. So yeah, that's cool. And let me use now again the reset so we can get the machine off. And I need to type the right stuff. Okay.
Right, so all the sectors have been cleared, which forces the plan to start again, and we're rescanning our environment. And again, we should see, I hope, once it starts, that, yep, there it goes, it's found a card, and it will be continuing in that vein. Let's just wait for that to finish for a second.
Mm-hmm.
And looks like it has. All right, so Mike, how might, or Diego, either of you, how might we query what has actually been found and show what's in the sectors?
Well, what I would have done if we were able to see the rich output in Teams would be to query these scanned sectors and filter the results. But I think I'll hand to Diego to do that in the notebook so we can see some pretty...
Well, just to mention that the interesting part is that here, Prof, I'm still remotely connected. So this front end, I'm using the VS Code extension, like you mentioned, but is connected remotely to the rover. So we're sharing the whole state with 3 different things. And this is the... we're going to look at the sector that we've been through, and let's see what we found. So this thing found a fighting energy. Awesome. These were empty. A 30, correct. And he saw this one twice, but then this one is the metal. And so that was the 3 types. So we reached the goal. And we only had to do 7 scan instead of having to go through the entire loop. So we saved quite a lot.
Yeah, that's fantastic. Okay, guys, so that's our demo. It's sad, as demos always are, that I think in 50 different trial runs, we've never had a problem with Teams displaying the output, and it won't this time. But we've also managed to show that you can get around that by using VS Code, which is fantastic. But let's chat about what we have shown in this lesson. Our class is completely remote. Everyone is remote, and we're working together in teams. Using Teams, we can query the robot and ask it about its capabilities. And we can also send it code to run. We can create, train, and retrain a model for classification. We've used energy cards, but you could use anything, any general household items, fruit and vegetables, whatever, mobile phones at home. Our class can independently advance the behavior of the robot's perceive, plan, and act stages. And this allows the teacher to organize the class into collaborating groups who work on specific behaviors. For example, one group could work on training the model and another on mapping and searching. We've shown that we can do a lot even within quite a constrained environment while working remotely. Note that we've not even driven the rover. We only use the camera. If we added driving in, we'd add a whole new set of exciting problems related to navigating an environment and also robot security. There's a landing page with a lot more information about our collaboration with Microsoft. You can access all the code in the GitHub repository. And remember that everything here is open source. .NET is, of course, open source, but so are our .NET and Python SDKs. They're also available on GitHub too. And you can interact with us within GitHub in the normal way. From this page, from the landing page that we see it linked to there, you'll also be able to find the answer to our treasure hunt question if you are interested in that. So go and check it out. And thanks very much. If anyone has any questions, please let us know.
Excellent. That was an amazing, amazing session. You know, it's live when demos take the time that they choose to.
It was my code broke it.
So we blame Diego.
Thank you.
Yeah.
Never.
Just kidding. That was amazing. We do have a couple questions that I'd love to cover with you guys in the last few minutes that we have here. So we'll go right to it. From Kathleen, what happens if the syntax is bad to the robot?
I think I can field this one, seeing as I'm the one always breaking it. Well, Diego, are we able to share the screen again? Can we get some output out? Is that possible, Diego?
Can we have an example of this one?
Let's put in a bad right line. Here we go.
It's gonna complain.
There we
It's
go.
another copy paste that you've.
So it handles it. It handles it correctly. Yeah, I mean, Stack Overflow normally works for me. I try very hard.
Oh, that commentary is great. Hate to break it to you, but
It doesn't run. I know.
You know, you want to let people down gently, really, don't you?
oh
It's
yeah,
important.
it's gonna be sad.
Not live on a conference.
One thing is that behind this, to use intelligence to answer you back about, you know, what type of code to type, suggestion, but also to show you what's available in the state. So when you connect to the bot with a richer editor, like, you know, Monaco editor, VS Code, and other editor like that, more focused to code editing, you get the whole rich experience. Teams is not designed for that. So that was for simplicity and the conversational aspect, but you can see now, like I was using VS Code will give you the full rich experience of intelligence. So even Mike would have got that piece of code right at this point.
Amazing. Well, we are right. Oh, sorry to interrupt you. We are right at time. So thank you all so much for joining us. That was an excellent session. If you missed any of it, you can go watch the recording on the stream. Otherwise, you can reach out to all of these lovely folks on Twitter or out to us if you have further questions. Thank you so much. And yeah, we look forward to seeing you guys again soon.
Thank you.
Thanks.
Thanks. Bye.
Alrighty, well, this has been so much fun. Thank you all for joining me here today. That is the end of my hosting part of this amazing event. I am going to pass the torch on to the amazing Kendra Havens. Hello, Kendra, how are you?
Hi, Jamie, I'm doing great.
I am loving your background. This is awesome.
It's my .NET bot is over here.
Wow, that's actually really great. All right, well, I'll let you take it away. Have fun.
Thank you so much. So our next speaker, I'm very excited to hear. Her name is Adora Nwodo. She's a software engineer at Microsoft, and she will be speaking all about .NET for infrastructure and automation. So if Nuado, yay! Hi, Dora.
Hi.
So you can take it away.
Okay. Thank you. Thank you, Kendra, for that introduction. I'm going to be talking about .NET for infrastructure automation, like she said. And the big word here for me is automation, right? We are at this part now where everything that we want to do is like, we don't want to spend time doing multiple things at the same time. We only want to focus on the things that require our time, and we want to automate the rest of it. And if we look at our lives today, a lot of things are automated for us because we have, virtual assistants, i.e. Cortana, to help us do that. We have different applications, different IoT devices that just help make our lives easier. And we are able to use code to automate like different mundane tasks in our lives, so that we can have time to do things that matter to us a lot. And this picture that's actually a picture of my hand. So this picture was taken by me 3 years ago at my graduation party. And it was a very hectic day for me because, or rather, it would have been a very hectic day for me because I planned the party myself, didn't outsource anything. So I had to plan for like food, I had to plan for music, and I had to make sure that people that were coming in were okay and there was power and everything. It was supposed to be a dinner party. And if not for this thing that we're talking about now, if technology did not exist, it would have been a disaster. But I was able to find playlists to serve as my music, and I was able to order food via an app, and that served as the food. And all I did was just sit back, relax, and enjoy the party that I planned, or didn't end up planning, because I don't know, somebody else somewhere did everything for me, someone else that I did not even know. And this is another example of something that could help, that you could do when you have your time back, right? So you could enjoy with family, you can enjoy with friends, you could go out and do things that you love, you could read a book, you could do a lot. You could do a lot with your time. The time that you get back as a result of being able to automate things, you could do a lot more with that time. So now, I've already talked about this before, where I said that we use code to automate mundane tasks in our lives. Okay, so now in this talk, I'm going to be sharing with you how you can automate the coding process. And before we go on, I want to tell you, or rather, I want to reassure you that you're not going to be writing code to automate the coding process and then think about writing code to automate the code that you're using to automate the coding process. That's not going to happen. What's going to basically happen, what I'm trying to talk about today, is that normally already, when we build applications, right, we have to deploy these applications somehow. So when you spend time writing code and you're building applications or you're updating apps that already exist, you want to be able to automate that process in a way, and you also want to be able to automate the deployment of your infrastructure in a way. And that's what this talk is going to be about, how we can write code to automate our infrastructure deployment, as opposed to doing it in a very manual or mundane, or even in old-fashioned infrastructure as code ways. But before we get to the main gist of the day, I would quickly want to introduce myself. My name is Adora, as Kendra mentioned. I'm a software engineer at Microsoft Mixed Reality, and I am a tech content creator at Adora Hack. Adora Hack is also the shirt I'm wearing, by the way, just in case you can see it. It's a thing that I created myself. It has a YouTube channel and I have a blog as well. And that's where I share things relating to, tech, and career growth and lifestyle as I'm learning every day, because I am a student at life. I'm the co-founder of OnStack, which is a community here in Lagos, Nigeria, that, as opposed to, normal talks, our meetups focus more on hands-on workshops, because we believe that many people learn by doing. I'm also on the advisory board of VRARA Nigeria, which is the Nigerian chapter of the Virtual Reality Augmented Reality Association globally. And you can find me on Twitter at Adora Nwodo. You can stop by if you want to say hi. So now let's talk about manual configurations. Before we appreciate what technology has done for us today, before we appreciate where we are now, we need to take, a trip down memory lane just to see what it was before. Right, with manual configurations, deployments are a lot slower because, they're done by us, right? So if you have 3 environments that you're supposed to be creating resources for, you're going to have to create all these resources one after the other for these 3 environments. And that can be slow, and that could also have a potential for introducing errors, because you might start creating something and then the first one you create might be done properly, and then the second one you might miss out something. And for that kind of thing, as well, as you create these resources, as you try to configure what the infrastructure for your application should look like, you're supposed to be documenting, as you go, because that's what everyone is going to be paying attention to. That's what everyone on your team, everyone working on this product that is going to be on that side is going to be relying on. And if anything happens for whatever reason and you have to, roll back, it's not as easy as, going to, revert a change in a PR that you made that spoiled something, because this requires manual work in a way, and it's a bit harder. It's kind of like suffering, to be honest. And that's kind of like a serious recipe for disaster. I'm going to talk about one very terrible thing that happens with manual configuration, which is configuration drift. Let's look at our 3 environments. So we have our dev environment, we have our staging environment, and we also have our production environment. When we started out, right, our dev environment, our staging environment, and our production environment looked alike, right? They only had a few things that were differentiating them. Like, let's say the config, if I had a web app, for example, right? The app service plan that I'm using might have been like a different tier. In this case, we have an Azure Function app, we have Cosmos DB, we have a Key Vault, and we have a storage account and some other configs in. Let's say something happens, I don't know, I'm on call and something goes wrong in production and it triggers an alert, and then I see this alert, and then I have to, go and fix it. And in the course of me fixing this thing, I make an update to my production environment, and this happens. So now my production environment, my staging environment doesn't mirror my production environment anymore. The production environment is slowly drifting away from the original way that it was configured, and that would be a problem. So now enter infrastructure as code. With all those things that I've said, I've talked about these things a lot. Why is IAC, infrastructure as code, important? Configurations are specified in code, right? Everything you do, nothing you do is going to be manual. Everything you do is going to be written as code, and then it's going to be automated in some way. So this prevents, the issues that I already talked about. You can test, you can version, and you can roll back your infrastructure gracefully. And I used the Git example. I used reversing a PR that made everything just, break essentially reverting that PR and taking your application back to a state that worked. And you can also do this with your infrastructure. If you write code to maybe add a new resource, to your infrastructure, and for whatever reason, something happens along the way, you could easily roll back and then figure out what happened and then fix it, and everyone will be okay. The next thing is you can automate your infrastructure deployments. So you can do infrastructure as code and with your CI/CD, and that could help automate the entire process, your infrastructure deployment, your code deployments in one pipeline, and all you had to do was just define what resources you want in code. And why are we using .NET? Okay, first of all, because we're at a .NET conference, and the next thing would be familiarity. My guess is a lot of people here watching either are familiar with the .NET stack or want to get familiar with the .NET stack. So this is a good place to start. You can reuse different coding constructs. You can express yourself in any way you'd like to express yourself in, using different programming constructs that you like, programming in any way that you like to program. And it also makes you productive because you have access to these different IDEs, you have access to these different tools and these other different things when you're writing .NET that makes your life a lot easier. So imagine having access to these tools as well when you're writing code for your apps and when you're writing code that defines the resources in your infrastructure. This is how you would define an Azure storage account in C# if you were using an infrastructure as code tool called Pulumi. Pulumi is a modern infrastructure as code tool that helps you create and manage your applications infrastructure with real life programming languages that you already are familiar with. So you don't need to, go and start learning something new. It helps you transfer your skills from one domain to the other. When I picked it up, it was pretty easy. I mean, I had to do some reading and I had to learn a bit, but it would have been easier than if I had to pick up an entirely new language, an entirely new way of doing things from the very beginning. Because I mean, I already write C#, I already write TypeScript. If you already write Python, if you already write Go, that's great. You could just take that energy into Pulumi and you can create all your infrastructure. And I think that that's something that is really amazing. So now let's get right into the case study of the day. Let's get right into using .NET to automate our infrastructure. And I'm going to introduce my friend here who happens to be a stick figure. Her name is Oge. Oge needs to create infrastructure for an Azure Functions app and deploy this to two environments, a dev environment and a production environment. So here's a list of resources that she needs. She needs an app service plan, she needs a storage account, and she needs a function app resource. So the first thing that I would do for Oge is to go to Azure and create a storage account. I'm creating a storage account manually, however, because Pulumi has two options for saving the state of your infrastructure. So that's how Pulumi works, right? It saves the state of the current infrastructure that you have in the entire application. And based on that state, if you want to do an update, it checks in with the state to know, what you're creating, what you're updating, what you're deleting, what you're replacing. So you can choose to use Pulumi's cloud, or you can choose to have your own custom backend. So I am going to Azure to create a storage account because I want to use my storage account as my own custom backend. So I'm going to create a storage account and call it Pulumi Store. And then I'm going to create a container and I'm going to call it Pulumi Container. I'm going to create that storage container in my Pulumi Store storage account. So now once I have that, I would keep the name of my storage container, the name of my storage account, and my storage account key somewhere because I'm going to need it in this next step. So now I launch PowerShell or any terminal that I like. Well, I can't launch PowerShell for this talk, so we just have to deal with PowerPoint. So we're going to log into Azure CLI first of all, so that we can be authenticated and we can do all the things we want to do with Pulumi. If you are doing this on the pipeline, you would be using a service principal authentication, which is different from using AZ CLI. But for the sake of this, we're going to log into Azure CLI, and now we have to set the environment variables. We have to set the name of our storage account, and we have to set the storage account key environment variables respectively. Then we need to install Pulumi. So I'm doing Choco install because I am on Windows. But if I was on a Mac, I would probably use Brew. And if I was on Linux, I would do it in a different way. And you can install this manually as well. You could always go to the Pulumi site and install Pulumi manually. But I am doing Choco install right here. I am creating an IAC working directory and CDing into that directory so that I can do all my Pulumi things there. And the next thing I'm going to do after that is log into Pulumi. I'm going to log in to my storage container as the backend, right? So that Pulumi can authenticate with Azure. Pulumi knows that my storage account is the backend, and whatever state is saved in that backend is the current state of my infrastructure. And the name of my storage account, name of my storage container is Pulumi container. So I log into that, and then I create a new Pulumi project in C#. And once I do this, this is what my terminal would look like. And then once you want to create the project, it's like a wizard. So they're going to ask you for the name of the project, the description, if you want to describe it, the name of your stack, right? So they're going to ask you for the name of your stack. And the first stack I created is a dev stack. And then because Oge wants to deploy this to 2 environments, I also created a prod stack. So think of a stack as a configuration for the different environments that you might have. So it might be different environments, it might be different regions, but you could have your stack, and your stack would have files, different files. So because I have a dev stack and a prod stack, I have a pulumi.dev.yaml and I have a pulumi.prod.yaml. So I can decide to add my own configs that I feel should be different. So if I have a dev stack, for example, and I want all my resources in dev to be deployed to West Europe, I can add the location in my config as West Europe, and then in my code, I can reference whatever the value of my config is and pass it as the locations that I want to be creating in. And this just allows me to specify things that would be different in the different configs, in the different stacks that I have. If I'm doing an app service plan and I'm thinking about, I don't need to have a premium, size or a premium tier for my dev stack. I could have my dev stack be a standard tier, and I could have my production stack be a premium V2. So I could specify different things in the different stacks, and that is not in any way coupled with the code I'm writing. All that Pulumi knows is that when Pulumi is running, all the commands it needs to run to update my infrastructure based on what stack I am currently on, Pulumi goes ahead to do what Pulumi has to do. And this, your program, this is your program.cs, and like your start.cs, if you were in Azure Functions, for example, this program.cs is the entry point to the code you're writing. And then what happens is that in your main method, you're calling deployment.runasync, and you're passing in the name of your class, which is my stack. So my stack is the name of the class where I am going to be defining all the Pulumi resources that I need. And it inherits the base class called stack. So this is my own version of my stack, right? I'm calling it my function app because I want to create a function app. I want to create an app service plan, I want to create a storage account as well. So I create my own function app, and I, inherit from the base class called stack, and I create my function app constructor. I specify all the names of the different resources I'm going to create, and I leave them in these different constants that are here. And I create a method called getAppSettingsMap, because my app settings should be an input map of strings. So I want to create a method that basically constructs the app settings map before I go ahead to add it to my function app. So now I also have an output. At the end, when I am done, creating all the resources I'm going to be creating in my function app, I want to return the function app URL. So I have this output string here as what I'm going to be returning. So now this is what my getAppSettingsMap method would look like. I just want to specify a cloud service config, and I want to set the cloud service config to whatever my configurations environment variable config is. And if we go back here, the env config in pulumi.dev is dev, and the env config in the other one is as it should be as well. So I set that, and then I return my app setting, and then I go ahead to get my app service plan size, my app service plan tier, what my environment is, and what my location is. I go ahead to get all of these things from my config, and I just have them saved in my variables to use when I'm ready to use them. I go ahead and create the resource group, because everything I create should be in a resource group. So I go ahead and I create a resource group with the resource group name that I specified. I'm passing the env also as part of the name, just so that I know which resource group is a dev resource group and which resource group is a prod resource group. So I'm creating a resource group in the location specified, and I'm passing the name of the resource group. I'm going ahead to create a storage account. So as opposed to doing this manually, I am doing this by writing code. So I'm writing code to create a resource group. I'm writing code to create a storage account. I'm writing code to create an app service plan, and I'm writing code that is going to create my function app. I'm passing in the name of the app. I'm passing in the storage account name because my function app needs a storage account. I'm passing in the ID of my app service plan, the location, the access key of my storage account, my resource group name, and the type, the identity that I want. I want a system assigned identity, the version of my function app, my app settings, and my site configs. So I'm passing in all these things. And the first time I was talking about running a Pulumi program that you specify, I said that you could use deployment.runasync and pass in the name of the class that implements stack. Another way you could do this is you could still have deployment.runasync, but now you can create an instance of the class. You can create an instance of the class you created that has all the resources defined in them, just in case you want to have access to the outputs. Because if you had done it in this way, you wouldn't have access to the outputs, which is our function app URL. In case you need to pass the function app URL somewhere else or you want to do something, writing it this way could help you achieve that. So now here, like I said, if you look at the code, I created a resource group, I created a storage account, an app service plan, and a function app. All we need to do at this point is run a Pulumi up. And once we run a Pulumi up, Pulumi is going to, go ahead and deploy all these and create this infrastructure for me in Azure. And if I go to the Azure portal, I'm going to see it there, right? And this is clearly it, right? So we can see that the sample Pulumi app dev sample Pulumi plan dev, and sample Pulumi store dev are 3 resources under the resource group sample Pulumi RG dev. If you want to cross-check the names, you could go back. So when I was getting ready for this talk, I actually wrote the code and did the deployment. So I took this screenshot as I was creating, and then I went to the portal immediately it was done and took this screenshot as well. So a few weeks later, the thing I talked about states with Pulumi, a few weeks later, Oge comes and she wants to, update her app, and she wants to add a key vault to her infra so that she can securely manage secrets. I don't want to spend time, talking about this here because it might mean like a few extra minutes. But I created this repo on GitHub. You can actually go and check it out. And this has the code for creating a function app and creating everything you need with even with the key vault. So you can go ahead and check this out. But I still took another screenshot of what it looked like after the second deployment, which was the key vault deployment. So the initial deployment 2 weeks ago was, me creating the resource group accounts, app service plan, and function app for Oge. And then in the next week or in the next 2 weeks, I have to create, a key vault. I have to add a secret to that key vault. Everything is done in Pulumi, by the way, and I have to set access policies on my key vault. And now if we look at what's currently happening here in the second terminal, we would see that, or let's go to the first terminal first. We would see that we have 5 resources to create, and Pulumi creates these 5 resources, which is, my custom resource, and then the resource group, the accounts, the plan, and the function app. These other 4 resources are in my custom resource, and that's why it's 5. So now let's go to 2 weeks after, right? I have my custom resource already, so Pulumi isn't creating that again because I just added it to my function app class. I didn't go and create like a new class. So now we can see here that the terminal says 4 to create and 5 unchanged, meaning nothing is going to happen to these 5 resources that I already had created. And Pulumi is aware that these 5 resources are there. And then I'm just going to create 4 more resources and get them added to that without tampering with these other 5 resources. And if I want to go ahead and delete one of the 5, I would see it in the terminal. I would see Pulumi telling me to delete in the terminal as well. So Pulumi manages all of that for you. All you need to do is write the code to manage your infrastructure, and Pulumi worries about, the states, what it's creating, what it's deleting, and how to go around managing the entire process. So write your code, run your Pulumi up to update your infrastructure, deploy your code to that infrastructure, go to sleep. That's all you need to do. If you need more information about doing infrastructure engineering with Pulumi, you can go to the Pulumi website. I think it's very comprehensive, actually. I didn't need like any external things. It's well written and it's easy to pick up. I also wrote an article on this a few months ago, and there's also an article on dev blogs where you can go read, and it could help you understand how to like build modern cloud applications with Pulumi and .NET Core. You could also look at this Medium article written by my coworker, Kende. She shared some light on what infrastructure as code is and how you can get started, and the differences between, declarative and imperative ways of doing IEC. Thank you so much for joining this talk.
Thank you so much, Adora. That was so cool. I always love seeing some Pulumi shout outs and sharing your code at the end. We love it. Kind of as you say, DevOps as code gets to benefit from like source control and whatnot. And then also being able to share DevOps scripts and everything on GitHub because they're now tracked and they're now, all like explicitly written out. It's a cool world to be in. Thank you so much for sharing.
Thank you.
All right. I don't think we quite have any time for questions. It's already about ready for the next talk. Next up is building your first Android application with Visual Studio and .NET. We have Shadrach Nusa coming up. Hi, Shadrach.
Hi, Kendra.
How are you doing?
Nice meeting you. I'm good. I'm good. I'm feeling good.
Excellent. This will take me back. Android Studio is one of the first things I used in college. It was pretty interesting, but let's take a look at what everything looks like in Visual Studio. You can take it away.
Sure. Hi, everyone. My name is Shadrach Inusa. I'm a Microsoft Student Ambassador based in Accra, Ghana. I'm so grateful. I'm so happy for joining this event. This is my first time having a conference or joining a conference and speaking on. I'm grateful to the .NET community.